So, when let's imagine कि you wake up in the morning, right? And then you have breakfast, right? Why do you need breakfast? Because your body wants energy, right? And why does it want energy? Because you will do some work throughout the day, right? Let's say you read books, let's say you go for a walk, or let's say you want to go for a ride on a bicycle, right? So everything which you do is called basically work. ठीक है? But they will identify कि what is work in domain of physics, right? Is studying just work, right? So is basically, let's say, holding a pair of cup of coffee on your hands is an example of work or not, right? So we'll have to be specific in physics, right? So in physics, the work will have a particular definition which we will see, right? So let's begin. So first of all, we'll start with the idea of energy stores, right? So what are energy stores? Can anyone tell me? Stores के meaning क्या होता है, right? It will basically save, right? So what will be an energy store? Yes, give me a guess. Mashal.
सर वहाँ जगह जो एनर्जी सेव होती है स्टोर होती है यस
Perfect, right? So basically, energy stores states that in how many forms. I have choosing a red marker, तो ये blue आ रहा है. So it tells you in which forms can energy be found, right? It tells in what forms can energy exist, right? In what form? So we have multiple forms of energy. We have gravitational potential energy, right? That is called GPE. We have kinetic energy. You will see in a while what are these. We have elastic potential energy, right? That is EPE, right? We have nuclear energy, right? And we have chemical energy, which is stored in our bodies, right? In batteries. Okay. We have chemical energy.
सर मैकेनिकल एनर्जी
Yeah, we also have mechanical energy, right? What else do we have? Is there anything left?
थर्मल एनर्जी
Yeah, we have thermal energy. That's
हीट
good.
एनर्जी और
Yeah, thermal energy. We have thermal energy that basically is friction, let's say. So we have these forms of energy which can exist, right? And there are many more. But in this syllabus, we'll stick to these particular types. Most popular are GPE in your syllabus: kinetic energy, thermal energy, elastic potential energy, right? And also nuclear energy in your future chapters, which you will see in your radioactivity, right? You will have fusion, fission, you will understand that how does nuclear energy is produced, right? So these are the forms of energy, right? So these are the states or the forms in which energy can exist, right? We will see in the future slides that what is gravitational potential energy, what is kinetic energy, okay, and so on and so forth, right? Okay, so the first of all, we have the first energy form is chemical energies, right? So can anyone tell me where can I found chemical energy in real life? Mashal, where can I get, where can I found basically attain chemical energy? Give me a real life example. Is Mashal here? Hello, Mashal. I guess Mashal is not able to speak. Mashal, are you here? Give me a thumbs up if you are here. Or I guess she is just having a cup of coffee and then. Okay, so what do you think? What is chemical energy? Where can I find chemical energy in your life? Don't read the slide. Be honest, okay? Just give me a guess. Mashal, yes. Okay, I guess she is somewhere where she cannot speak. पर्दा आप बताएं.
सर इन आवर सेल्स हमारे अंदर आई गेस बैटरीज
Okay.
और हाँ
Right. So chemical energy is basically it's stored in basically food and fuel, right? So fuels can be in different multiple forms. If you go on a bike, on a car, you have petrol, right? You have gasoline. So that stores energy. And let's say if you talk about yourself, like you have food, right? You eat food, you have breakfast, you eat meat. Okay? Or what do you get from eating food? You get energy, right? That is stored in your body, right? So the body which basically is stored in food and fuels are called chemical energy, right? So where can I find it? I can find it in food and fuels, okay? And fuels are pretty common over here, which you basically see in your chemistry classes. You have gasoline, right? And how do we get gasoline? We get gasoline from crude oil, right? So you do some processes to get your gasoline over here.
So we do fractional distillation.
Yeah, we have fractional distillation and processes. I don't want to repeat those in class of physics because some people who are not taking chemistry might get confused, right? So these are basically the concentrated stores of the chemical energy. What does concentrated means? It means that it contains heavy amounts of chemicals energy over here, right? So how does chemical energy comes from food, right? So that is the question over here. Okay, sir, I have had breakfast, right? So I feel energetic, right? So how does the process, how does the food when it goes inside my body gives me chemical energy, right? So that is through. So how, the question is, how does the food gives me energy, right? That should be the question you had. So the answer for this is basically it goes through some series of chemical reaction in the body, which is not part of your physics syllabus. So just understand that if food goes inside your body, there's some chemical reactions which basically breaks down the glucose and gives some energy into your body, and that is pumped into your different parts of your body through your heart, right? And you can then lift, you can run, you can breathe, and you can do respiration, so on and so forth, right? Okay, so now the next question is, how does fuel, how does fuel generates energy? So can you answer me this? Kid? Imagine you have a petrol in your car, right? So how does petrol produces energy in the car to keep it running?
सर
Yes.
फ्यूल जलता है, वी बर्न द फ्यूल आई गेस, क्योंकि इंजन में कुछ ऐसी चीज
Mhm.
होती है जो फ्यूल को बर्न करता है.
Good, right? So imagine that this is your engine over here, right? And you supply in fuel over here, right? You are basically supplying fuel into your engine, and this gives you energy, right? And how does this give you energy? Basically, what happens? The fuel is combusted, right? It is burnt under with the ration of basically oxygen. It burns with oxygen and then produces carbon dioxide and some energy over here, right? So this is how the fuel produces energy in an engine or a boiler, right? How does battery store energy? So battery store energy basically in form of chemical energy again. Okay. So how can you extract energy? Imagine okay, you will study this in your electrical chapter over here in physics. So what happens? Imagine this is your battery. This is your battery over here, right? This is your battery. And let's say the battery is of 9 volts. Okay. It has stored energy in form of what? In form of chemical energy. What happens if you want to use this energy? You will connect this particular circuit. Let me just fix my plus sign. It's pretty messy. So what do? I basically do this. Okay. I connect this with the load. Okay. Or let's say a lamp. And this basically leads to what? My lamp glows. Right. And this basically consumes the chemical energy stored inside the battery, and we will see कि current क्या होता है, what is voltage in your upcoming chapter, right? So that's how chemical energy is utilized and used in getting energy over here, right? How do I burn fuel? How do I get energy from fuel? How do I get chemical energy from battery, right? That's how. So the next in line, if we have gravitational potential energy, right? So this is pretty interesting over here. It is just a phenomenon of gravity, right? If we don't have gravity, there is no GPE, right? How? Let's see this. Okay, let's see. Imagine that you are going on a building. This is your building over here. Oh, this is your building. Okay. And imagine you go at the top of a building and you, let's say, throw a ball, right? Let's say tennis ball. Let me just draw the ball here just to show good animation. The ball is basically thrown from here, right? You throw the ball here, right? Okay. First of all, when you take the ball at this particular point, right? Let's say this point is called point A, and this point at the ground level is called ground height G. So when you basically take the ball at this particular point, it has certain height, right? It has certain height over here that is called H, right? So at this point, at point A, it has gravitational potential energy, right? Okay, you can show it by GPE, or you can also show it like this, okay? PE, right? Both of them are correct. There are some notations that which is used to just show, okay, what form of energy are you representing over here, right? Okay, so what is this? First of all, that is the question, right? Sir, what is gravitational potential energy, right? So what is basically as follow, right? So this is the energy which is basically cause is produced due to its position, right? If you place your object at the bottom of the ground, okay, the gravitational potential energy will be zero, right? If you take it to a certain height edge, now gravitational potential energy has some value, right? So it depends upon the vertical position over here, right? Let me just highlight over here what the vertical position from the surface of the ground, right? So that is your reason that why gravitational potential energy exists, right? So it exists due to a certain height, right? If you take an object, any object, your mobile phone, or let's say you go for paragliding from aeroplane, right? You jump from an aeroplane, you have a certain gravitational potential energy at the top, right? Imagine this now, right? Imagine you're going on an airplane, right? You are doing paragliding, right? You're doing paragliding over here, and this is the surface of the earth, right? This is your ground level over here. So you are at a certain height, right? So at the point of your start of your journey, right, you will have maximum gravitational potential energy, right? So then this particular energy causes you to accelerate downwards, right? So this is the this is the beauty of gravity, right? If there was no gravity, you won't have gravitational potential energy, right? So an example of this is as follows, right? A body above the Earth's surface, like water in a mountain, right? So has energy which is stored as gravitational potential energy. You would have seen, let's say, if you went to Kashmir, or let's say any northern areas in Pakistan or any country, right? You would have seen a mountain, right? Let's say this is a mountain over here. Let me just draw a realistic mountain, which will look like this. Imagine this is a mountain, right? And the water is flowing from the mountain, right? Like this, and this is the reservoir, right? So why does it flow downwards, right? Why doesn't go upwards? Okay, because at this point it has gravitational potential energy because it is at a certain height from the ground, right? This is edge. So now it has enough energy to basically flow, right? So we will see that what happens when the water starts to flow, right? That some conversation, basically not conversation, the gravitational potential energy will basically start to convert to other forms, right? So this is what is gravitational potential energy. Is it clear? What is GPE and how is it produced? If it is, give me a thumbs up. Clear to Mashal. Okay. Clear to Varda. Okay. Yeah. We're just now learning some types of energy store, right? We will do this types in detail in the upcoming slide, right? So don't worry. कि sir हम क्या कर रहे हैं. The third type of energy store is elastic potential. Elastic strain energy. Okay. It is same as elastic potential energy, right? You might call it elastic potential energy. It is also same, right? Okay. So they both are same. So don't be confused from here, right? Okay, so imagine this. We have gravitational potential energy. So how is it produced? If you go above the ground level to a certain height, you will have gravitational potential energy, right? Similarly, you have elastic potential energy, right? Imagine this. Imagine this. You have a spring, right? Which is without the load, right? This is without load, okay? It has no load. It has no load, right? And it has the original length of L, right? So now imagine the second scenario which has the load on it. Okay. Now imagine it has a load like this. It has a load of, let's say, weight W, right? And this was the original length, and it has extended by some length, right? Which is basically this, right? Let me call it delta X, right? We have seen this in the Hooke's law, right? So again, what is happening? If you apply a force, it has traveled some distance in the same direction as the force, right? So the force is in this direction, and the extension is also in this direction, right? So this basically leads to some form of energy, right? And that form of energy is called elastic potential energy. Elastic potential slash strain energy, right? They both are same. Strain energy, right? So this is very similar concept, right? They all depends upon some distance, right? This gravitational potential energy depends upon the distance traveled from the surface of the Earth to a certain height. This depends upon extension, right? How much are you extending or compressing a certain elastical object, right? So that will have elastic strain energy, right? So again, let's start to in the theory what the theory is saying. This is energy an object has because of its initial condition, right? So imagine it was unextended over here. It was unextended, right? So the now this is condition one, condition A. So what is condition B over here? Okay, it become extended, right? So this change in condition that leads to an extension of delta x will cause it to have energy that is called elastic strain or elastic potential energy, right? We want to make sure that it does not cross its elastic potential limit, right? That is the limit of proportionality. If you see this, if you have extension against force, right? We have seen this graph, right, before in in your Hooke's law, that this is the point P after which it cannot regain its original shape, right? So we will derive this in a while, right? We will see this, okay, what is the formula of elastic potential energy in the upcoming slide, right? So you can just, if you want to visualize in real life example, you can just see this particular diagram. Okay, what is happening over here? Can you explain that how is the strain energy being saved over here? How is strain energy being produced in this particular bow example over here? Can you explain this?
Sir, the person when he knocks an arrow and stretches the string to pull it back, तो
Mm-hmm.
उसमें फोर्स लगती है और वायर लाइक जो है ना स्ट्रिंग वो स्ट्रेच होती है
Mm-hmm.
तो उसमें स्ट्रेन लगता है.
Hmm. Good. Right. So imagine the bow was unextended. It had a original length of L, right? So when you extend the spring, this basically the bow string over here. So the length increased by some delta X, right? So that delta X led to the store of strain energy in in the string, which basically when you leave the arrow, that energy is transferred to the bow as form of kinetic energy, right? So basically what is happening over here? We will study this. कि कैसे होता है. So this particular string has elastic strain energy. ठीक है, let's stick to the book terms that has elastic strain energy, right? As soon as he leaves the arrow, that energy is transferred to the arrow in form of kinetic energy, right? That makes sense, right? You will study this in detail, that how does conservation of law of energy applies in every way of life, right? So I hope this is clear. If it is clear, thumbs up quickly. Elastic strain energy, clear to Mashal, clear to Varda, and clear to, is it clear to me? Yes, no, it's a clear to me. Okay, good. Now, the most interesting or the most popular kid in the town is kinetic energy, right? So everyone basically loves this principle because it's easy to understand and you can find this useful in real life situation, right? And you basically travel on cars, your buses, your school buses, and you have this, okay? This form of energy is pretty common, right? That is the kinetic energy, right? So what is kinetic energy? The definition is pretty simple. That any moving object has kinetic energy. That's it. Any moving object has kinetic energy, and faster it moves, the more the kinetic energy, right? So we will derive some relation, right? We will derive that kinetic energy has some relation with velocity, right? We will derive this in a while, that why does it depends upon speed, right? So the greater the speed, the greater the kinetic energy, right? So imagine this. Imagine you're going on a car, right? Let me just draw a Ferrari or a Bugatti. Let me just draw a Toyota. Okay, 1990 Toyota. Right? Imagine you're going on a road, you go from point A to point B, and let's say Varda is driving the car, right? Okay, and the speed with which Varda is moving in a car is speed V. It has certain mass, that is m, right? So she's moving. Okay, let's say the observer is standing over here. He observes, let's say this is Maeve over here, right? Maeve is observing Varda driving a car, right? So Maeve would say, okay, according to my classes of physics, Varda has kinetic energy, right? Because she a study in the class Kesar ने बोला था कि any moving object has kinetic energy. So yes, since Varda is moving in a car and she is sitting inside the car, so if the car is moving, so is Varda, right? So they has a certain kinetic energy, right? So this is very real life, and this is interesting since it is easy to calculate this. It's easy to calculate everything, right? So, but you find most common questions in O levels, A levels, moving around kinetic energy and gravitational potential energy, right? So another example for this is a hammer, right? Imagine you're driving a nail into the wood or into the, let's say, into the wall, right, using a hammer. So what happens? You basically first of all have kinetic energy of the hammer, which basically goes to another forms, right? So what is happening over here? Imagine okay, this is your wall, and we have Mashal over here now. Okay, Mashal is trying to, let's say, put up a painting on a wall, right? So she has a hammer, right? And she's basically driving the nail inside the hammer, right? Sorry, inside the wall. And this is the wall over here. So what is she doing is basically she's accelerating the hammer until it hits the basically the nail over here, right? So hammer has velocities, hammer also has mass. So initially, hammer has what? Hammer has kinetic energy, and this converts into other forms, which you will see. Which what are the other forms? Okay, when she basically strikes the nail over here, right? So what is happening over here? Hammer has kinetic energy, has kinetic energy, and after she hits, basically she makes contact with the nail. Okay, so after contact, it converts into other forms. So what are these other forms? We will see in a while, right? We will see this in a while. Okay, this is kinetic energy over here, right? Now we have electrostatic form of energy, which you will see in your electricity chapter in detail. So it just understand this that energy can be stored also in by charge objects, right? So we have protons, we have electrons, right? We will see that how is energy stored by charge objects that has basically that produces electrostatic energy. So how can I basically transfer energy in form of electrical current, right? So again, an example for this can be, imagine you have a battery, right? B. So if you want to, let's say, light up a lamp, right? So how does the lamp gets energy? Is basically through electrostatic energy, right? So the current is basically flowing in the circuit, right? This current goes through the lamp, and it produces some basically it starts up the circuit, and it basically makes the lamp to glow, right? So how this particular lamp gets energy through electrostatic energy. So we will study this in chapter number 4 in detail, that how does this energy is produced, how does this transfer, and how do we calculate this, right? So the most scary, or we can say, when you want to produce this form of energy, you need to be pretty cautious, right? Because this particular energy is produced through reaction which are very risky, right? Either it is fission, right? We will study what is fission, or it is fusion, right? So fusion is basically going inside sun's core, right? Inside sun's core, fusion is happening, right? And the both of the processes basically produces huge amount of energy, right? Huge amount of energy. There has been cases where the nuclear power plants, okay, let's imagine these are nuclear power plants. So when they were producing energy, they didn't knew that the reaction can become dangerous, and it led to an explosion also, right? So these are very dangerous form of energy production. But again, this is one of the sources which can be used to basically generate energy, right? So we have one nuclear power plant in Karachi also, that is called Canap. Okay. So this is a Karachi nuclear power plant. Okay. It is near Bin Qasim, right? If I'm not wrong. Yeah, it's near Bin Qasim. Not Bin Qasim, Hawke's Bay. Have you seen Hawke's Bay Beach? Anyone? If yes, give me a thumbs up.
Yes.
Okay. If you go towards Hawke's Bay Beach, you have some unauthorized, basically authorized area where you cannot enter. Okay, so over there you'll find these power plants, and we have Canap 1, Canap 2. So there are two types of Canap power plants. So Canap 1 is now it has been shut down. Canap 2 is active, right? We are still producing energy from this, but the kind of these sort of power plants are very expensive, because the material which is used to create this should be very strong, so that they can stop fission and fusion process it. Okay, so again, in simple terms, what is nuclear energy? So the energy stored in nucleus of an atom, right, is called nuclear energy. Right, we will study this in detail in chapter of radioactivity, right, in your physics content or nuclear physics. That is in your chapter section 5. We will study this in detail. What is fusion, and what is fusion, what are these equations, and how is the energy produced, right? Just imagine this. Okay, this is one of the form of energy which can be produced by extracting energy in the stored in the nucleus of an atom, right? Okay. The last one we have over here is the internal energy, right? Over here. So internal energy आप लोगों ने पढ़ी, if you take chemistry you might know this in detail, what is internal energy. So just if I want to skim it out, so this is also called thermal energy, and it is the final fate of it is the final fate of the other energy stores over here, right? So it's conduction, convection, radiation through which I can transfer this. So in physics, when I deal, basically internal energy is called basically heat energy over here, right? It is just the heat energy. So every reaction, right? Whether it is GPE, the gravitational potential energy, it is kinetic energy, it is basically, let's say, uh, nuclear energy, right? Nuclear energy, whether it is उसके अलावा electrostatic energy, right? So on and so forth. Every reaction basically finally leads to the production of certain energy, which is called thermal energy. And that is simply what? It is the energy lost to surrounding, right? Whatever processes takes place, the final product is always heat energy, okay, in every process. So that heat energy goes to surroundings, okay. So just imagine that in every process you will have internal energy produced, right? Okay. Does that make sense till now? So these are all the types of energy which you have in your syllabus. If all of them are clear, give me a thumbs up. Okay, clear to Mashal. Good. Clear to Varda. And what about Maeve? Maeve, is it clear or you lost? Maeve, are you here? I guess now Maeve is having a cup of coffee, right? Okay. Yes. Okay. So yes, good. Okay, so now we have discussed what are energy stores and what form of energy stores we can have. We can have seven sorts of energy stores, starting from gravitational potential energy till internal energy. But how does energy transfer take place, right? How can I observe one form of energy? How can I observe? The question is, how can I observe? How can I observe the energy transfer, right? So I know, okay, these are the energy states, energy stores available, but how can I observe it goes from one form to another form, right? So first of all, what is energy transfer? Can anyone tell me what is energy transfer? What is energy transfer? Give me a guess. Can be wrong, can be correct. No worries. Yes. Give me a guess. एनर्जी ट्रांसफर क्या होता है? आप ये पढ़ चुके हैं, पता है? So basically, energy transfer. Yes, Mashal. Mashal, you're not audible. Hello. I guess she is having some mic issues. So let me just tell you guys, imagine you are basically, let's start a story, right? Let's start a story. Let me just tell you a story. So I like to take stories. Imagine this is 8 a.m., right? You just had breakfast, right? So you had breakfast, right? Now let's say after 8 a.m., you basically, let's say at 10 a.m., we go for a jog, right? And then let's say after 10 a.m., around let's say 1 p.m., you basically go for a hike, right? And let's say after that, you are pretty energetic, right? You're trying to break your boundaries, and then you go for paragliding, right? ठीक है जी. And this is around, let's say, 9 p.m., right? It takes time. Not 9 p.m., should be in the morning. How can you navigate in night? Let's say it is 5 p.m., right? So what happens when you wake up, right? You had breakfast, okay? So breakfast goes into your body has chemical energy, right? So in starting of your day, you have chemical energy, right? Okay जी. So imagine that you woke up in the morning, you had breakfast, so you got energy, chemical energy in your body, right? You go for a jog. So you go for a jog, okay? And in jogging means what? You are running, right? You are running. Oh my God, good drawing. Right. So you are running with certain speed over here. So you have what? You have kinetic energy, right? So what is happening in this stage? So chemical energy is getting transferred to chemical kinetic energy, right? Okay. So you are hiking, okay? Now you are hiking over here. Let's say this is a mountain which you want to hike, right? So you are hiking this particular mountain. Again, you have pretty huge amounts of energy. You're basically constantly taking, let's say, chocolate bar, right? So you have energy. So what is happening over here? You want to hike this particular mountain, which is at a certain particular height, right? Height edge, right? Let's say you reach this particular peak after some time, right? Okay, yes. Oh my God, it is pretty fluffy over here. Let me just draw it correctly. You reach the top of the mountain and you have conquered the world. You are at the top, right? At a certain height edge. So what happened? You now have gravitational potential energy, right? So now what happened? Your kinetic energy transferred from what to what? To gravitational potential energy, right? Okay. So now you do what? You take your backpack of your parachute and you want to hike. Sorry, you want to paraglide, right? So from the same mountain, right? You basically jump, right? With the parachute, obviously. So you are now paragliding over. Okay. So now what is happening, right? So now you had initially gravitational potential energy, right? That has now converted to what? You're moving downward with the speed of v, again back to kinetic energy, right? So now at this point you have kinetic energy, right? Yes, at this point you have gravitational potential energy, right? So at this point, what happened? Your GPE converted to kinetic energy, right? So that's how conservation or basic transfer of energy takes place, right? According to your let's say activities, it continuously changes, right? So in every stage, you would have thermal energy, right? At every stage, you would be losing some energy in form of thermal energy, right? So over here, you would have a plus. Let me just draw it from purple color. You would have plus thermal energy, right? So I'm gonna show TE for thermal energy, right? Thermal energy, right? Okay. So you will have a plus thermal energy here also, right? Plus thermal energy here, plus thermal energy here, right? Because when you were moving, you would have air resistance, right? Air resistance will lead to basically loss of energy in form of heat energy, right? And some plus some energy here. When you're paragliding, you have again air resistance that would basically move against you. They will try to stop you. Okay. So again, this again leads to what? Just loss of energy, right? So that will produce the idea of efficiency. So what is efficiency? So you might have a thought, right? Okay, sir, it means that we are losing some energy. If we are losing some energy, that means that we are not so efficient, right? So we will discuss the term efficiency in the end of the chapter. What is efficiency and how do we basically define efficiency, right? And what factors does lead to the decrease in efficiency and what factors leads to an increase in efficiency, right? Is this example clear? How does energy transfer takes place and what is energy transfer? If yes, thumbs up, clear to me, clear to Mashal, clear to Varda, good. Okay. So another example is shown in your textbook. That is pretty simple, right? So what is happening over here? You basically had the weight initially over here. Let me just choose the same color. Should be same as this. So you had the initial weight over here, right? So what happened as soon as you release the weight, right? It goes down. So initially it had gravitational potential energy, your weight, right? So what that does is basically it moves the motor, right? It moves the motor, okay? And this particular phenomena leads to what? Production of electrical energy, right? So this is a generator which produces energy, right? Which is called electrical energy, right? It produces electrical energy, right? Or you can say okay, electrostatic energy. So what happens is this, okay, now this is transferred to basically charge up a battery, right? This charges a battery over here, okay? And this battery goes to basically connect your lamp over here, okay? So what is the overall circuitry over here if I draw block level diagrams? So a motor, you have a motor, and this goes to your generator, right? You have a generator, You have a generator, and this basically does what? It basically charges a battery. It charges the battery, right? And it does what? It does basically now what? It causes the electricity to flow. Okay? It it basically lights up the lamp. That is as simple as it can be. Right? Lights up the lamp. Okay. So if I draw the circuit of this, okay, this is the block level diagram. This is the block level diagram. Block level diagram. Okay. Now if I draw the circuit of this particular example, so the circuit would look like this, right? Circuit is an electrical form of representation, right? So this is a battery over here, okay, and this is your lamp, right? And this is your 4-volt battery as shown over here, okay, and this is your lamp, which is this one, right? The lamp of 1.25 volts, right? And these are wires, right? These are wires. The blue ones are wires which connects these particular poles, right? So these are also wires. These are wires. Wires क्या होते हैं? They basically connect the terminal, right? Okay. And what happens as soon as you connect the circuit, the current flows, right? The current flows and again does what? It lights up your lamp, right? So now can anyone tell me what is the transfer of energy? What is the energy transfer? Energy transfer over here. So we have seen this in the example, right? So chemical energy goes to kinetic energy goes to gravitational potential energy, and then gravitational potential energy goes back to kinetic energy, right? So now over here, what is happening? You can use this block level diagram to explain. Yes, I'm going to give you 1 minute to think, and those who want to answer, raise your hand. It's pretty interesting over here, right? You have this transfer of energy everywhere. Okay, whether it is your television, whether it is your, let's say, your iron, whether it is your microwave, whether it is your bicycle, you can just name anything. There is an energy transfer equation basically for that. Yes, so for this particular example, what form of energy transfer is happening over here? You have a minute to think upon, and yes, Vardha.
I was going to say electrical to motor, या वो जो
Mm-hmm.
mechanical energy,
But what
mechanical
is the
energy.
starting point over here? Starting point तो ये है ना हमारे पास ये.
Oh, right. So then from gravitational potential energy to electrical energy, then from electrical energy to mechanical energy. है ना?
मैंने कल कहाँ से आ गए?
अच्छा फिर okay, mechanical
You're
नहीं
close.
हुई.
You're close. You're close. Gravitational. This basically moves the motor over here. Then this motor basically uh, produces electrical energy using a generator over here, and then basically it is transferred to your lamp. Okay, and this produces heat energy, right? Because when you basically see when you touch a lamp, just touch a lamp which is glowing, it is basically producing some heat energy, right? It would be hot, right? So you're close, you were almost there, but you miss one thing is that it starts from gravitational, it goes to mechanical. Okay? So what happens? It starts from gravitational potential energy, right? And it goes to what? It goes to mechanical energy because it moves the motor. Motor is moving, so that is mechanical energy, right? Mechanical energy. And this mechanical energy basically goes to generator, right? That produces what? That produces electrostatic energy, that is electrical energy, right? And this basically converts to what? The heat energy of the lamp, right? Heat plus light energy, right? Light plus heat energy. But it is also glowing, right? So that is the overall energy transfer that is happening over here, right? So if you just name any system in your basically in your house, in the world, right? Just you can just go for a walk and just try to observe something, right? And the energy transfer would take place in every part of the world, right? Is this example clear? If it is clear, give me a thumbs up. Clear to Mashal, Mir, and what about Vardha? Clear to Vardha, right? So if you want to read more about this, you have this slide over here, right? Which has the entire details over here, right? So सब कुछ जो हमने बताया तो यहाँ पे लिखा हुआ है, right? Okay. Summary, right? What sorts of energy can we have, right? We can have the following four main categories over here. We can have mechanical, electrical working, right? Let me just choose a good color. This one is good. So the energy basically can be transferred from four ways, okay? Mechanical, electrical working, waves, heating, right? So in summary, energy can be transferred between stored in the following ways, right? So mechanical working, right? Let's say if you're moving a generator. So in this example, we saw, okay, the weight had initial gravitational potential energy, right? It basically moved a motor over here, so it has mechanical energy, right? So what is happening? The action of a force, right? Because weight is a force, right? Weight is a force. It led to causing the motor to move, and this led to the production of the remaining energy in this particular energy transfer equation, right? So then we can have electrical working, right? Let's say we are lighting up the lamp, right? So how is the lamp lighting up? Because of the electrical energy, the charges are moving and it is basically lighting up the lamp, right? That converts to heat plus light energy. Okay. We can also have waves, which are basically transferring energy, right? Imagine that you are standing over here, and if I play some music over here, right? Let's say if I'm playing music over here, so what happens? It produces sound waves. Okay. Sound wave basically looks like this. Let me just draw correct representation of sound waves. So it goes in compression and reflections, right? Right. So then you basically hear the sound over here, right? So waves basically also transfer energy over here. You can also basically observe transfer of energy through heating. Okay. You will have conduction, convection, and radiation. We'll study this in detail in chapter of waves, right? And how does particles act in conduction process, convection process, and radiation process over here, right? So these are the four ways through which energy can be transferred, right? So yeah, that summarizes the entire energy transfer section over here, right? Okay, some real life examples. I want you to guys to explain scenario A, B and C, right? So I would call A के लिए मशाल and B के लिए वर्दा and C के लिए C तो हमने कर लिया है and D के लिए मेव. Okay, so you have a minute to think about this. Okay, what energy transfer is taking place in these examples?
Which one should I do again?
Uh, you have you have D, right? So D के लिए you have a dam over here, right? We have a dam here. This is a dam, right? Which stores energy, stores water, and the water is basically coming down through his pipe. Okay, this is a water pipe.
Yeah.
Water pipe. Okay, since it is huge because water is flowing through this pipe, should be able to let out a huge amount of water, right? Right, and basically water pipes. इसके बाद you will have some turbine. ठीक है, after this water pipe you have some turbines, right? Afterwards you will have some turbines, which basically causes and then generator, right? So this completes the entire dam, right? The hydroelectric power production, right? So just forget this part. I'm just writing this down for your future uh, direction, right? So starting with A, Mashal. Mashal, able to speak? Is your mic working? I guess Mashal, your mic is not working. Till then, Vardha can start with part B. Vardha, what is happening in
Sir, in part B, the thing is, there is a man and he's like putting an arrow on a bow. So the
B?
string, जो string होती है वो
No, Vardha. B is this one.
जी
B is this one.
अच्छा बी ओके सॉरी मुझे लगा वो भी है
Yeah.
ये हीटर है ना हाँ सो बेसिकली सर्किट में से एनर्जी जाती है टू द हीटर और फिर वो हीटर टर्न्स द इलेक्ट्रिकल एनर्जी इनटू हीट एनर्जी और फिर वो कमरे को हीट करता है यस
Yes. Okay. Okay. ठीक है. So yeah. What about scenario number D, Maeve? Just give me a guess. Whatever you understand, right?
Fuji.
Mm-hmm. Okay.
Fuji, I think, will be kinetic energy because
Mm-hmm.
it'll depend on the water flow, the speed of it.
Good. So initially, what energy does it have? The water. You can see the dam is at certain height, right? This is the dam.
Yeah.
It is at a certain height, which is this height edge. So initially, over here, water has basically what it has gravitational potential energy, right? And then
Yeah.
as soon as it goes down through the pipe, it has kinetic energy. Okay.
Yeah.
So as per
Yep.
the yeah, that's what. Now, as Vardha said, okay, sir, that this particular this is a heater, right? And this basically gives out heat energy, right? So what is happening over here? It basically gets energy from electrical energy, right? From your power sockets, it gets electrical energy, right? It converts this energy into form of electromagnetic radiation, right? EMI. It is electromagnetic radiation that is your heat energy, right? Which basically makes your room to be comfortable, right? In winter. So if winters are near, winter is coming, right? So you should be able to understand your flow. And I have a comment here from from Mashal. So she has stated that sir, for A, when the roller coaster is pulled up, it reaches the top, it stores a lot of gravitational potential energy, and as it basically goes down the top, it basically gains kinetic energy. Right? That's good, right? So imagine the roller coaster is here, right? As soon as it basically goes down, so at this point, it would have gravitational potential energy, and as soon basically as it starts to move down, it gains kinetic energy, right? So this in a roller coaster, the transfer is only between kinetic and gravitational, right? So it converts from kinetic and goes to gravitational potential energy, then again gravitational potential energy, then it basically jumps back and forth, right? That's how roller coaster I made, right? Okay, so yeah, there are some examples over here. You can read them in detail in this particular summary. So we have discussed this in detail also, right? So let's move on to the basically I'm gonna stop after gravitational potential energy, right? So let's start, right? How do we measure it, right? We have understood, okay, sir, these are the types of energies and how does the energy transfers, okay? We have seen some examples in real life also, but how do we measure it? How do we calculate this, right? That is the main thing. So every physicist wants to also calculate this because when you want to, let's say, design a roller coaster, right? You want to know, okay, what amount of energy does it needs over here, right? X joules. Because if it does not have that energy, okay, let's say if it is moving up from here, right? It had to move, let's say, up from here, okay? So what energy, basically, how much kinetic energy should be stored initially in this roller coaster to basically reach at this particular point, right? Let me name this a point B. This is point A, right? So what energy is point to reach from point A to B needs to be calculated first, right? I need this amount of energy. So for this amount of energy, I would have to launch the roller coaster at certain speed, right? So who have basically taken a ride on a roller coaster? Raise your hands. Who has taken a ride on a roller coaster? I believe everyone should have. Vardha has been on a roller coaster. What about Maeve and Mashal? Are you guys scared from a roller coaster? Okay, I guess. Okay, Maeve is scared. Okay. So what happens? You would have observed that initially when the roller coaster starts, it has some engine, right? वो आपको basically थोड़ा लेके जाता है top के ऊपर, right? It was smaller one, right? Yeah. So what happens is basically the roller coaster has a small engine. It basically is active in the start of the ride, right? So when it goes, let me just draw a diagram over here that you understand it in detail. Okay, Mashal has been on a roller coaster ride. That's good. So imagine this: कि you have a roller coaster ride. It goes basically like this, right? So initially, when you start your journey, so there is a small engine, right, which produces the kinetic energy, right? Okay, that much so that it can reach the top, right? It can reach the top, which has gravitational potential energy, and then the engine turns off and it goes automatically, right? And you would observe that the first peak is always the maximum, right? After this, the peaks are smaller, right? And why is that? We see it in detail, right? In some sections of questions and MCQ, right? And as soon as the ride ends, it basically comes to a halt here, right? So this is an interesting design which you should observe, right, when you sit on a roller coaster, right? So they are dealing with all these conversions which we are studying right now. So they have done the calculations, they have designed perfectly so that they save the fuel and maximize their profits, right? Okay. So yeah, now let's start. How do we calculate work done, right? How do we find the amount of work which we need to do for a specific part of, okay, of let's say designing a roller coaster or doing some task, right? Okay, so in an energy transfer, work is done, right? Obviously, work is done. How can I transfer energy if I'm not providing any input work, right? If I don't have any, let's say, input energy, how would the energy transfer, right? First of all, I need to produce energy, right? Okay. So let's first of all, I should have some initial energy, okay, which should basically then transfer to other form, right? Okay, other forms, right? Okay. So what is work? Basically, the work done is the measure of amount of energy transfer, right? So it's measured in joules. We will study this. How do we derive this in a while, right? So for example, if you exert an upward force of 10 Newton to raise a stone steadily to a height of vertically 1.5 meters, the mechanical energy is 15 joule, right? We will study how do we find this. So they are telling you, imagine you rose, let's say this was the stone initially. Let me just use a different color. This was the stone at height 0. This is height 0 meters. And he took the stone to a height of, this is position A, this is position B. So at position B, the height is what it is 1.5 meters, right? And you basically provide a force of how many newtons? Upward force of 10 newtons to basically lift it upwards, right? So from this equation, which you will see के कैसे आती है, so you know what is work. So work done is basically the force into the distance travel in the same direction, right? You can see the distance is also in this direction. The force is also in this direction, right? They should be parallel to each other, right? So you can just simply find the work by multiplying both of the things, right? So for this example, how can I find work? It would be what? It would be simply the force is 10 newtons, the distance is 1.5 meters, right? Therefore, the work done by, let's say, the let's say, which is basically picking up the stone, right, is going to be 15 joules, right? So that is the initial start, right? So you start with the basic understanding of work. That is from a simple scenario over here, right? So I hope it is clear. If it is clear, give me a thumbs up. Clear to me. Good. Clear to Varda. Waiting for Mashal. Clear to Mashal also. Okay. So now we have the principle of conservation of energy, right? That is pretty important. So why do we have a principle of conservation of energy? First, can anyone tell me first of all, okay, what is the principle of conservation of energy?
Sir, the principle of conservation of energy
Mm-hmm.
is that energy cannot be destroyed or created.
Okay. And why do we basically use this principle? Why is it important?
सर अगर एनर्जी डिस्ट्रॉय होएगी तो फिर हम एनर्जी को स्टोर नहीं कर पाएंगे रीयूज नहीं कर पाएंगे
Good. Close. Close. Okay. Start thinking about Big Bang when the life was made, right? So basically, what is happening over here? Let me just end over here, right? So let me just give you an example because I have another class in 10 minutes. So yeah. So imagine this scenario over here. Okay, this was Big Bang, right? And everything basically exploded. Push, 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 right? So it produced the initial energy, right? A total initial energy which was produced in this Big Bang, right? Now after this we have basically millions of galaxies, and within those we have millions of solar systems, and within every solar systems we have, let's say, at least a dozen of planets, right? Within those planets we have billions of, let's say, there are earths, there is one earth on at least one solar system, right? Let's say. So we have millions of living things, right? Let's imagine this. Okay. So the initial energy which basically was produced, right, is now being transferred across the chain, right? It has been transferred across the chain. right? If you think, okay, now basically the initial energy was produced from here, right? All the energy was here. All the energy produced came from here. Produced came from here, right? So जितनी एनर्जी प्रोड्यूस हो चुकी है उतनी ही आगे एग्जिस्ट करनी चाहिए, राइट? यू कैन नॉट प्रोड्यूस मोर एनर्जी, ठीक है, which was not initially produced after Big Bang, right? So neither can be destroyed, right? Because if it is destroyed, it means ke where did the energy go, right? If acha, we have a link of energy and mass also, right? So don't take this way too seriously, right? Just just understand, right? So energy is also linked with mass. It is also linked with mass, right? Can anyone tell me is mass, let's say imagine if you go to Mars or let's say another universe, would your mass change? Would your mass change? We had done this in your chapter fourth, right? Okay, if we basically go to moon and you measure your mass and you measure your weight, right? So what thing remains same?
So your mass will remain same.
Yeah, so the mass is conserved in every part of the universe, right? So if it is conserved, so should be energy, right? Because they are linked together. I will show you the question which links energy and mass in your upcoming chapters, not now, because you get confused, right? So since mass is conserved, so should be energy, right? So what does this says here? This states that energy cannot be created. Okay, cannot create energy, neither can destroy it, right? So if you do this, that means you're breaking some laws of physics, or we might have not captured that part of physics yet, right? Cannot be destroyed also. Okay? So this is pretty interesting. Think about this in your homes, right? थोड़ा बहुत सोचें, watch some videos on YouTube, ठीक है? That would give you an interesting idea, ठीक है? That means के it is always conserved, right? So imagine this. Imagine this example. Okay. Imagine ke you throw us. Let's say again you are running, right? Okay, you are running. You had chemical energy initially. ठीक है? You are running. Okay. So now you have chemical energy. You have a certain velocity v. Now you have kinetic energy. Okay. Now let's say you stopped over here. Right? Let's say you basically went towards a certain road which was basically slanted, right? You went up across the height edge, right? Okay. So at this particular point, when you reach here, you have gravitational potential, right? So what is the transfer of energy over here? The transfer of energy is as follows, which is from chemical energy to kinetic energy. ठीक है? It to basically it leads to gravitational potential energy, right? So practically, you would observe कि this gravitational potential energy क्या हो रही है? Change नहीं हो रहा. So this gravitational potential energy would be slightly lesser than the chemical energy, right? But it should not be because we are not capturing the thermal energy, right? Because when you are running, you also have air resistance, right? You have air resistance, which basically leads to a loss of energy, right? So you have a plus small thermal energy also, okay? Thermal energy over here. At this point, you have thermal energy that is TE. And if you take it into your equation, okay, so that would lead to a same answer, right? So this would show, okay, at the end of the entire your jog or running, okay. So your chemical energy is basically same as gravitational potential energy plus some thermal energy, right? Okay, so it is always conserved over here, right? This triple sign means CQ means here it is similar, right? So for that we have a conservation of energy principle, right? When the universe was born, right? So जो भी energy release हुई थी ना, उतनी energy रहेगी till the end of life, right? So it cannot be created. You cannot create more energy out of nothing, right? Let's say if you produce heat energy, so there would be some kinetic energy or some other form of energy that converted into heat energy, right? So you cannot create anything out of nothing, right? So out of nothing basically was the Big Bang, Okay, it just happened and everything was formed, right? So physicists are again thinking about okay, what was the thing which caused the Big Bang again, but they are still lost, right? So they are discovering as soon as they discover it, so they will talk about it soon, right? So we talked about some energy mass relation over here, right? The famous Einstein equation behind it over here. So we can research upon this. Okay, how does mass is conserved, right? So we're talking about the conservation of energy. That also applies that the mass should also be conserved, right? We have learned this in your initial chapters. Okay, mass throughout the universe is same, right? That the mass does not change. Why? Because the energy is also conserved, right? So energy and mass are interlinked together. And the Einstein gave the equation for this that was E equals to mc square, right? So we talk about this in later chapter, later section of the chapter. Okay. Okay, so now the principle of conservation of energy for using one example over here, right? Okay, so let me just start with the background over here. Okay, what are they trying to convey over here? So ultimately, all energy transfers result in the surroundings being heated, right? So we, as Mashal said in the start case, sir, we have the one form of energy as thermal energy, and that is the last state of every form of energy, right? You can see over here whether it is. Let me show you the yeah, internal energy is also called thermal energy. So whether it is GPE, whether it is kinetic energy, whether it is nuclear electrostatic, whatever energy which we have learned in the previous slides, they all end up in the last state, that is thermal energy, right? So this is just stating that fact over here. Okay, let me just take you over there. It's here, right? So ultimately, all energy results in the energy being sent to the surrounding in form of heat energy, right? That is work done against friction. Okay, if you basically friction is a loss, the lossy work done over here, which means that the energy is going to be lost, right? That is into thermal energy. Energy is wasted over here. That is spread out and increasingly more difficult to use. Okay, so for example, okay, let's start an example over here to make sense here. What are we talking about over here, right? When a brick falls, a gravitational potential energy transferred. Let me just give you the example over here in a diagrammatic way so that makes more sense. Imagine here you have, let me just draw the boundary of the ground using a black highlighter. Hello G, who is the host now?
Me,
Can you share the host right to me? ठीक है,
you're already the host, sir. So
ठीक है, सही है. So yeah, my internet might die in between, ठीक है? So just hold on. So this is the brick over here, right? The brick is falling, right? It basically, let's say it is at a certain height over here from the ground. That is height h, right? And we have seen that if the object is a certain height, so it would have gravitational potential energy, right? So imagine you just throw the brick from the ground, right? Towards the ground. So what happens? It would accelerate. It would go in this direction, right? So initially it had gravitational potential energy. So now this will convert into kinetic energy, right? So as soon as the brick hits the particular ground over here, so you would see that you will hear some sounds also, right? Sounds plus heat energy, right? So that is what is produced after contact, right? That converts into thermal plus sound energy, right? So if I try to draw the entire chain of conservation or the conversion of energy, that is initially it was gravitation potential energy, right? Then it went to kinetic energy, okay? And as soon as it hit, basically makes contact with the ground, converts into sound plus thermal energy, right? So whatever scenario given in your MCQs or in your theory exams, make sure to link, right? Okay, what is happening throughout the process, right? And let's say if it is speeding up, then it has kinetic energy. If it is at the certain height, it has gravitational potential energy, right? If it is hitting or if it's basically getting making contact with the ground, it would have thermal plus sound energy, right? So you should make these connections always, right? So if they ask you to make the entire energy change, so that's how you do it, right? Okay, so इन लोगों ने यहाँ पे यही बताया हुआ है लोग, ठीक है? If it seems in a transfer that some energy has disappeared, the lost energy is often transferred into non-useful thermal energy, right? So they are just saying कि you cannot say कि sir initially I had gravitational potential energy, right? And at the end I have, let's say, only kinetic energy, right? So this will not be balanced out, right? They will not be equal because there is also small portion, the small portion of sound plus heat energy, right? So if you miss this, your side will not be balanced out and you would say, yes, sir, my energy has disappeared, right? Energy cannot disappear, right? It is always there, okay? So you would have to find out the remaining versions in which the energy has converted to, okay? So that is the point over here. So this appears to be the fate of all energy in the universe, and is one reason why new sources of useful energy have to be developed, right? So they are saying that this particular energy, which we have seen, this particular part of the energy, let me just make a oval over here. This part energy is basically useless, right? Why it is useless? Because it is loss, right? It is the loss in the system, right? So this is basically energy loss. So you have lost the energy in form of this particular sources. Okay, so this does what? It reduces your efficiency, right? We will see it in a while. What is efficiency? Chapter in the section of power. So efficiency is basically how efficient is your system, right? कि जो आपने input energy दी है, is the input energy equal to your output energy, right? Because यहाँ पे input energy is this, right? That is your gravitational potential energy, and the output is basically this, right? How much it is speeding up, right? If it is not same, that means that some energy is getting lost, right? So that leads to a less efficient system over here, right? So that is what they're trying to say over here, right? Does that make sense? If it does make sense, give me a thumbs up. Okay, makes sense to Hamza, makes sense to Mashal and Ruba. What about Vardha? Okay, makes sense to Vardha. Maeve, is it clear? Okay, clear to Maeve also. That's good, right? So stay active on your thumbs up. Okay. So this is how conservation of energy principle works, and in this we have some useful energy output. Okay, so this is useful output, right? This is useful output. This is useful because this is causing the object to speed up, right? And this particular part is useless, right? It is a loss, right? It is leading to loss in energy. It just producing. It is basically produced due to friction, right? And friction is a component which causes loss, energy loss, right? Okay. अच्छा जी ये है this is for a dam, right? This is the energy transfer for a dam, hydroelectric power, right? So for this, I'm going to draw a diagram, right? Let me show off my skills. So this is pretty important and it comes in your questions, right? The dam example. So let me just try to draw a dam over here. So your dam should look like this. Let's say this is a wall over here, right? This is a wall, and on the left you have water, right? You have the water supplies, the reservoir. Okay, the water basically would flow from here, right? It flows here and then through this particular pipe like this. Then it has some certain section over here. It has motor, right? And then this motor links generator right over here, right? Okay. Then at the output, I have my transmission, right? That is my PMTs, right? Then this goes to your house, right? This goes to your houses, and this is basically the final output over here. Okay. This entire system is called hydroelectric power, right? This is hydroelectric power system, right? That's how dam works. HGP, right? Okay, so what is happening over here, right? This is the water over here, right? It has, it is particularly at a certain height over here, right? It is at a height h, right? It is at a height h. So at this initial point, the water would have what? Basically, it would have gravitational potential energy, right? So at this point, it has gravitational potential energy. As soon as I basically open the valve, as soon as the water flows out of this pipe and to the motor, turbine, ठीक है? Basically, this is a turbine over here, right? It's called turbine. I just labeled it motor. ठीक है? So this is basically the water is flowing, right, with a speed of v. So now, after as soon as it starts to move, the water has kinetic energy, right? The water has kinetic energy, right? So what is a turbine? Turbine is basically sort of a huge fans. They have huge fans like this, okay? The huge fan like this, okay? As the water gushes through it, okay, it causes the turbine to move, okay? So now this turbine is basically producing mechanical power, mechanical energy, right? And this is linked with the generator, right? And this generator basically produces what? Electrical energy, right? And this electrical energy then comes to your house, Right? That's how the entire system works. So if I try to draw the entire block level, the flow diagram of energy, that will look like this, right? It has initially GPE, then it converts to kinetic energy of the water, right? Then that particular water produces mechanical energy because it rotates the turbine. Okay, that produces mechanical energy. What is mechanical energy? It is produced when a turbine or some object is basically rotating, right, or moving. That's how also uh, the windmill works, right? The wind energy, and then it is linked with the generator, which produces electrical energy, right? That's how the entire chain of hydroelectric power works, right? So that is what is written over here. This is just stating the blocks. Okay, I have drawn over there. Okay, so we have high level reservoir, then it goes to water turbine, then it goes to generator, right? So what is the energy transfer which is taking place? So it is gravitational potential energy of water converts to kinetic energy of falling water, and then converts to kinetic energy of rotating turbine. That is mechanical energy. दोनों सेम बात है. And then converts to different energy stores. ठीक है, जो मैंने आपको बताया कि it is mechanical plus electrical, right? And in every stage, we have a certain loss, right? That is energy transferred by heating or sound wave, right? Because when the water is moving with such a pressure, so it also produces sound wave, right? So we have always at every stage we have losses, right? Plus losses, okay? Plus losses and plus losses, okay? And plus losses, okay? And what are these losses? If I try to define losses, so losses are basically your sound plus heat energy, thermal energy, right? So that is what is produced in every stage, and that links to basically the loss. Okay. And that leads to what? Less efficiency, right? So it basically makes the system less efficient. So your efficiency basically drops if you have losses. Okay. So is this example clear? If it is clear, give me a thumbs up. Clear to Varda, Mashal, Hamza, Maeve, Ruba? Clear है? Good.
Yes, sir.
ठीक है. So yeah, that is some my show off of my drawing skills, and that is the block level diagram over here. So now we have kinetic energy, right? So the most awaited phenomenon, which is pretty famous in physics, right? From O levels, it will go till A2 levels. Okay, this formula works everywhere, right? And what is kinetic energy? Mashal did explain in the start. Okay, it is, sir, the energy possessed by any moving object, right? So imagine, okay, if let's say if there is Ruba over here, if Ruba is running, right? So she has kinetic energy, right? The energy which she possesses is basically, let me just draw her eyes. Okay. So she has kinetic energy, right? So imagine, okay, if a car is moving, right? If a car is moving, again the same direction with the speed v, again it has kinetic energy, right? Imagine, imagine an ant, okay? Let me try to draw the ant over here. It has a big head and the small legs. Oh my God, क्या बना रही हूँ? Imagine कि it's an ant, and if it is moving with a certain v, let's say the v is 0.0001 meter per second, it's pretty small, right? Again, it has kinetic energy, right? It's pretty small for us, but it is huge for that particular ant, right? At a macroscopic level. So how? Basically, the question comes here, sir, how do we calculate this, right? The formula for finding the kinetic energy is as follows, right? Some people show as this E subscript K, okay? And some people can write it down as this kinetic energy. So both are correct, right? You can use any notation, okay, whatever you want to use. So this is just notation, right? How do you represent kinetic energy? Both are fine. Okay? If you use this in exam or this in my test also, that is fine. Okay? And how does it basically links with the mass? So let's say Ruba has certain mass, the car has certain mass, and ant has certain mass, right? So the mass is going to be also linking with the kinetic energy. Okay? So the formula which links kinetic energy is this. Okay? It is equals to half into mass into velocity squared, right? So if I try to create relation, so your kinetic energy is proportional to mass. So greater the mass, greater the kinetic energy, and it is proportional to the square of speed, right? So what is this particular thing says over here? Imagine you had a car. Imagine you had a car, right, which is moving at a certain v speed, right? So the relation of kinetic energy and the speed is basically this. The Ek is proportional to v squared. Now imagine the same scenario. This is at position A. Let's say at point B, the speed becomes double, right? The speed basically doubles. Let's say you are speeding up, right? It's a highway and you want to speed up. Now the speed of the car is 2v. So what would happen to the kinetic energy? It would be as follows. It is proportional to 2v whole square, right? So kinetic energy would be basically now 4v square, right? So if you double the speed, the kinetic energy increases by 4 times. Okay, that is the relation of kinetic energy and speed. And mass and speed are basically directly proportional to each other. If you double the mass, the kinetic energy doubles. Okay. Okay. This is an example over here. So what are they saying? Since Ek, the kinetic energy, depends upon v square, a high-speed vehicle at traveling at 1000 km per hour has 100 times the kinetic energy that is at traveling at 100 km per hour. ठीक है जी. So इसका मीनिंग क्या है? इसको देखते हैं. Let me just show you this. You have a car. You have two scenarios. You have scenario one. You have scenario two. Right? And at this scenario, the car is moving at a speed of 1000 km per hour. It's not practically possible, but let's see it is at this speed, right? Let's say it is a miraculous vehicle over here, and you have another vehicle which is traveling at 100 km per hour, right? So it has kinetic energy one, EK1, and the kinetic energy of this car, let's say, is called EK2. Let's try to create relation between EK1 and EK2, right? So EK1, okay, is again proportional to. Let me just write down the value here. Let's say the masses are same, right? The mass is same on a car, right? We're talking about the same car. So EK1 is going to be half M. The V of the first car is 1000 squared, right? What about EK2? The kinetic energy of the second car is going to be half. Since the masses of both the cars are same, it's going to be 100 squared, right? So let's find the ratio of both of the car, right? Let's find the ratio of the energies. So what is EK1 upon EK2? I just want to find how does their kinetic energy vary. Right? So I'm just dividing both of the things. This is equation one. This is equation two. So I'm dividing basically one by two, right? So it's going to be half m into 1000 squared divided by half m into 100 squared, right? So this cancels out because masses are same and half cancels out. Okay. So we are left with what? EK1 upon EK2 equals to 1000 squared upon 100 squared. So if you do this, what do you get? So you get 100, right? You get 100. So this is equals to basically kinetic energy of car 1 upon kinetic energy of car 2. So what is the relation of kinetic energy 1? That is EK1. If I send this over here, so your EK1 is 100 times EK2. And so the kinetic energy of the car 1 is 100 times than of the kinetic energy of car 2. Okay? So you can see the relation is of squared, right? The relation is V squared. Okay? Does that make sense? So the easier way for doing this was as follows. Okay, so the easier way was what? I just did the lamba tarika just to explain to this clearly to you guys. So the easier way is this case. The car one is this and the car two is this. Okay, this is car one. It is at a speed, let's say 1000, right? And this is car two. This is car one. This is car two. And the car two is at a speed of 100, right? So let's find that this is V1, this is V2. Let's find the ratio, right? What is EK correlation? It's half mv square, right? So let's find the ratio of the speeds, right? So V1 upon V2 is 1000 upon 100. So it's basically 10 times, right? So the V1 upon V2 ratio is 10 times, right? So the V1 is equals to basically 10 times of V2, right? So if I want to relate V1 in terms of V2, it is 10 times of V2, right? That makes sense, right? So if I want to relate kinetic energy for car 1, let's say for the car 1, it was proportional to V2 squared. For car 2, it would be what? The EK1 would be proportional to V1 square, right? So what is V1 in terms of V2? It is 10 times of V2, right? हमने इससे निकाला ना, इससे निकाला हम लोगों ने. So just put in this into this equation. So get the relation directly. So EK1 is proportional to what? 10 V1, 10 V2 whole square, right? So your EK1 is basically proportional to what? 100 times V2 squared, right? So your EK1 is proportional to 100 times of V2 square. That is, it has increased by a factor of 100. Does that make sense? I guess दोनों जो आपको आसान लगे, you can use that, ठीक है? Either option number one or option number two. Let me just save it and take you back to the slide. ठीक है? If you find this simpler, so this is fine also. If you find this simpler, this is also fine, right? So if it is clear, give me a thumbs up. This is just a comparison ki how does kinetic energy depends upon mass and velocity. ठीक है, clear to Ruba, Mir and Varda. What about Mashal and Hamza? Mashal, are you here? Hello guys, Mashal and Hamza. Am I audible? Hello. Check 1, 2, 3. Am I audible? Am I audible? Someone please tell me. Or was I just speaking to go? ठीक है जी. So let's now go on. Now you have an idea okay, what is the kinetic energy and how does it relate with mass, how does it relate with speed, right? So now I have a surprise for you guys. That is a question, right? So you have 2 minutes to solve this question. So you want to find the kinetic energy of a football of mass 0.4 kg and moving with a speed of 20 meter per second, right? Let's say there is a footballer over here. Oh my God. There's a footballer here, right? And this is the goal, right? Let's say this is Hamza. Hamza shoots. Let's say Hamza did a pass, right? And the ball is moving in this direction, okay, with the speed v and it has mass m, right? So you want to find the kinetic energy with which the ball is moving, right? This is the goal post. Let me just make it blue. Let me know when you're done and raise your hand if you're done again. Okay, so before acha, also we forgot one thing, the SI unit, right? So what is the SI unit for this over here? Since it is energy, right? Energy is measured in joules, right? So the SI unit for kinetic energy is also joules, that is capital J. Okay, guys, I believe everyone is done. So let's solve this question, right? So first of all, when you start, you should always write down okay, what is given to you, right? So you're given this, you're given कि mass is 0.4 kg. The mass should always be taken in kilograms, right? And the speed with which the ball is moving, football is moving, that is 20 meter per second. That is again in the standard units. So you want to find what? You want to find the kinetic energy with which the football is moving, right? The EK. So let's find this particular thing. That is very simple, straightforward. So your EK is half mv square, right? Just put in the values over here. So half into 0.4, that is your mass, into v square. That is 20 squared, right? So therefore, your kinetic energy comes out to be what? It's half into 0.4, that is 0.2, and 0.2 into 400 is going to be 40 something. 80. Sorry, 80 joules. That is your answer. Yes, Hamza? So let's continue from here, right? Am I audible clearly? ठीक है, good. So जिसका आंसर मैच हो रहा है, from my answer, give me a thumbs up. I believe everyone should be correct. It's a basic formula. Yeah. मशाल का सेम है, वर्दा का सेम है, मशाल एंड हमजा सबका सेम है. That's good, right? Okay, so now we have gravitational potential energy, right? So we have discussed K, what is it, but how do we calculate this, right? That is what we will derive first of all, and then we will also do an example, right? So gravitational potential energy, right? So Ruba, can you explain this? Mashal did explain this in the start, so can you now explain this again to us? So what is gravitational potential energy? Can you just give
Uh,
an idea? Yeah.
so the gravitational potential energy is possessed by an object due to change in its position, and the formula is mgh.
फॉर्मूला गायब
potential
है।
energy is equal to mh.
ठीक है, गुड, सही है। सो इट इज प्रेटी सिंपल, राइट? सो imagine this is the surface of the earth. Let me just draw a realistic surface. Let me just use this. Oh, no, 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 this. Let's say this is the surface of the earth, right? This is the surface of the earth, and that should be uniform. Yeah, this is the surface, right? Let's say the ground, right? Surface of earth. Okay, and let's say we just zoom in over here, right? We just zoom in over here. So it almost becomes flat, right? Like this. Okay, it is a flat surface. Okay, now we place an object over here, that is M. So it has again a height of 0, right? So initially it has gravitational potential energy of 0, right? Because there is no change in height, right? Since again we're talking about energies, the SI unit for this particular quantity is again joules, right? That is again joules. That is capital J. Okay. So now let's say we lift the object up by a certain height, right? Let's say the height is h. Now it has some certain gravitational potential energy, right? So we can now realize the relation between the height and the gravitational potential energy, right? They are directly proportional to each other, right? If there is no height, there is no gravitational potential energy. If there is height, there is gravitational potential energy, right? That is as follows in the example, right? Yeah. So how do we define gravitational potential energy? It is an energy which is basically possessed by an object due to change in its height or position, right? Okay, this is the definition of GPE. So an object above the Earth's surface is considered to have gained an amount of gravitational potential energy equal to work done. Okay, that has been done by the gravity. Okay, to lift an object of mass m to a vertical height of delta h at a place where the Earth's gravitational field strength is g, it needs a force equal to and opposite to the weight, right? So we will derive this in a while. So this is the part of derivation. Okay, this is a part of derivation which we will do in a while. Okay, so this is till here. Basically, we are defining what is gravitational potential energy. So this is the definition of it. Right? I hope it makes sense. Now let's derive it, right? So this is your mass m, right? Mass m, and this is the height it has gained, height delta h, right? Why are we taking delta h over here? It's the change in height, right? The final height is, let's say, the final height is h2, and the initial height when the object was at rest at the bottom was h1, right? So you can see k h1 is 0 meters, right? If we take surface as a reference, right? So our surface of Earth is a reference over here, and h2 is basically something, right? Let's say x meters. So the delta h is h2 minus h1, right? So it's the change in height, right? So imagine this. So now let's recall some work done, right? So we have done this. So what is work done, by the way? If you want to apply a force and it travels some distance in the same direction of the force, this is called work done, right? So how do you define work done? Anyone? So work done is basically force into distance, right? Keeping in mind that the distance and the force are in same direction over here, right? So similarly, if you see this particular scenario, the object is getting pulled down by the gravity. Okay, that is its weight, right? So basically lift this object, I would have to provide a constant but opposite force so that the object moves at a constant speed, right? At the top. So this is the force which I am applying, right? Right? To lift an object over here. Okay. And the height is basically what? It is the distance traveled, right? It is also equal to the distance traveled by the object in the direction of the force, right? The force is also in the same direction, right? And the distance is also in the same direction of it. So they are both parallel to each other. So I can start deriving this particular equation from a definition of work done, right? So what is work done? So work done is the force into distance traveled in the same direction, right? Traveled in the same direction, right? So यहाँ पे I want to provide, so this work done is called basically the gravitational potential energy EP, and the basically to lift an object up at a constant speed, I would have to basically provide what? This is W over here. Okay. So to compensate this, in order to lift this object at a constant speed, okay, I want to provide an opposite force. That should be what? Equals to the weight, right? So F should be equals to the weight over here, right? So my F is simply weight, right? So I can replace the force by weight over here. Okay. And the distance traveled is basically delta H, right? So what is weight? How do I find weight? So weight is equals to mass times gravitational field strength, right? So if I put this into this formula, I would get my relation, right? Let me fix my arrow. So if I put this into the formula, I will get my relation, right? That is, therefore, your gravitational potential energy equals to mg into delta H, and therefore your gravitational potential energy is mg delta H, right? That is how you derive the formula, and this is the formula which basically you need to calculate gravitational potential energy, right? So over here, what is m? What is m over here? What is m? Anyone? M is your mass of
Mass.
the, yeah, इतना confused क्यों हुआ इसमें तो शांत है तो. So the mass of the object, right? And your G is your gravitational field strength. Gravitational field strength, right? So in your O-level course, for GCE it is 9.81, for IGCSE it is 10, right? Sorry, for GCE it is 10, for IGCSE you use 9.8. Okay. So depending upon your board, you can choose this value, 10 Newton per kg or 9.8 Newton per kg, right? So that is given in your formula sheet, right? In your exam, you can use the value from there. So your delta H is your change in height. Mass is in kg, right? The mass is in kg, and this is change in height, which should be always in meters, right? So this is, and the SI unit for this particular quantity is joules. That is capital G, right? So that's how you measure energy, right? So if it is clear, the derivation is clear, and the definition is clear, give me a thumbs up. Subhanallah. Sorry. So it's clear to Ruba, Hamza. What about others? Clear to Varda, Mashal, and Maeve. Clear or not? Clear to Mashal. What about Maeve? Okay, good. So if it is clear, again, a question to test you guys. Start this. So यहाँ पे you're taking 9.8 Newton per kg, right? You want to find the mgh, right? The gravitational potential measure. So what is the scenario over here? I have the scenario again. This is your ground level, and this is the mass which is lifted by some height. Okay, that is the height which is lifted up by is delta H is basically the delta H over here, and you have its mass which is 0.1 kg, right? So you want to find at this particular height what is the value of its gravitational potential energy, or this. Okay, either way it works. Okay. So you want to find basically E subscript P. You have 2 minutes. If you're done, raise your hands. So let me just do it and then you compare the answer, right? So again, you either in your exam either can draw a diagram quickly, or if you don't want to, you just quickly write what is given to you, right? Either way works. Okay. So आपको mass दी हुई है, आपको height दी हुई है by which it is lifted vertically upwards, right? It is vertically. Okay. That is important. The height is 1 meter over here. So we just came to realize the formula for gravitational potential energy, which was as follows. So your EP is mgh, right? So if you put in the values, your mass is 0.1 kg, gravitational field strength is 9.8, right? And your height is given to be as 1. So this is your gravitational potential energy value, that is 0.9. Okay. Joules, that is the answer. Okay. I hope that everyone got the same answer. I believe you all. So how would basically the transfer of energy takes place between the potential and kinetic energy, right? Okay, so let's start the experiment, right? Let's start the experiment. So I want you to take a great sort of attention over here, right? So scenario one क्या है हमारे पास? Scenario one is this. Okay, we have a ground over here. Let me just draw the ground from a black color. Let's say the ball is here, right? Let me just choose green. The ball is here, right? Has mass m, and it is at a certain height, which is delta h. ठीक है जी. So we learned कि how what is gravitational potential energy? It is the energy possessed by an object when it is lifted from the ground at a certain height, right? So over here it is at rest. So all of the energy of this particular body is available in form of gravitational potential energy, right? So let me write one equation over here. That is total energy, right? Total energy of the ball, right? That can be either GPE plus KE depending upon scenario, right? I'm gonna call it TE. So TE is basically, let me fix the notation जो आपने book में use करी हुई ताकि आप लोग confuse ना होने. In book they have used EP. ठीक है? So let me just fix the notation so that you don't get confused. It is gravitational potential energy plus kinetic energy, right? So it's going to be EP plus EK, right? So that is a generic form of total energy of the system, right? So over here, the entire energy is present in only EP form, right? And your EK is zero because it is at rest at this point, right? Let's say you're holding the ball at here. Okay, so the total energy at this particular instance is only available in form of EP. That is gravitational potential energy, right? And how can you find this? You know the formula, right? So you know the formulas for finding EP. That is equals to mg delta H. Yes, Maeve, you have a question? Okay, good. So maybe we are just doing an example to basically relate how is energy transfer taking place. How does energy transfer from potential to kinetic and kinetic to potential basically of throwing a ball, right? And then how can we find kinetic energy over here? That is equals to half mv square, right? Half mv square. Okay. This is scenario one, right? This is ground. So now let's imagine scenario number two. The ball is falling, right? The ball is falling. Okay. So let me just write it down also. Okay. Ball is held at delta H, right? Scenario number two is ball is falling, right? Again, the same scenario over here, the ground. Oh my God, that became pretty thick. This is the ground over here. And now the ball is basically falling. Let's say this was the initial height with which it was basically thrown, or let's say left. Now the ball is here. Now the ball is here, right? It is also at a certain height, which is, let me call it H1, and it is also falling with certain speed, right? So over here at this instant, what would be the forms of energy available? Can anyone tell me? At this particular scenario, when the ball is falling and it is at a certain height h, it has also speed. What forms of energy are available in the system of the ball?
Sir, kinetic energy.
And
and gravitational potential energy.
Tension.
yeah, both are present, right? Because वो ground से ऊपर भी है और उसकी speed भी है, ठीक है? So the total energy of the system will be as follows. It would be containing a certain part of elastic gravitational potential energy plus a certain part of kinetic energy, right? And this would give you total energy of the system at this scenario over here. So this would equal this, right? Because total energy should remain consistent, right? Same. That is the law of conservation of energy, that you cannot create energy, neither can destroy it, right? So we are assuming over here that the losses are negligible, right? That there is no air resistance, there is no friction. So we can assume this particular scenario. Okay. Okay, Ji. So now last scenario over here is the following, right? That is when the ball hits the ground, right? And it basically stops. Let's say it stops. It does not rebound. Okay. The last scenario is, let me choose right here. चाहिए pencil here. Make it more simple. Nah, not good. The last scenario is basically the ball hits the ground and stops. We're assuming that there are no resistive forces, there is no friction, there are no losses, right? It's an ideal condition, right? So now again we have the ground over here. We have the ground here, and we have the same. Let me just write down the reference height over here. This was the reference height at which it was thrown, right? It was dropped. Now the ball is here, right? M. Okay. So at this point, it would basically be hitting with certain speed, right? But the height over here with reference to ground is zero now. Okay. So now, what would be the total energy at this particular instant? Okay, it hits the ground with a certain speed and stops. So at this instant, when it is basically about to hit, okay, and it is very close to the ground, that is approximately the height above ground is zero. So what is the energy available in the system? Is it in form of kinetic energy? Is it in form of kinetic energy and gravitational potential energy, or is it only gravitational potential energy? Yes, give me a guess.
Sir, only gravitational.
Only gravitational potential energy. But what do you think about this? Height is zero.
Sir, only kinetic energy?
Yeah, the GP at this level will be zero. Okay. At this point, the kinetic energy was zero. Okay. Okay. So you can just see the differences over here, right? So at this point, when it is hitting the ground surface, so the energy available is only in form of kinetic energy, right? That is EK, right? So these are the scenarios of the falling of the ball, right? So you can, this is also stated over here, K. This is your, at this point, you have this scenario over here. Okay, that your kinetic energy will be zero, but since it was stationary over here, it was at rest when it was thrown or dropped. Okay, at the center, at the basically any point between the starting and the ending point. This is the ending point over here. Okay, and this is the starting point over here, right? So between at these 2 points, the energy would be available in both the forms, right? However, and when it hits the ground, only kinetic energy is available, right? And the potential energy is zero. So why is this coming over here? Why do we have EK equals to mg delta H? Yes, anyone? Okay, so this comes from here, right? Because in the start, we learned when the ball was about to get dropped, okay, the energy was available in form of gravitational potential energy, right? And how do I find gravitational potential energy? So your EPA is going to be mg delta H, right? So total energy available in the system, okay, is mg delta H, right? So it remains consistent throughout, okay? Over here, this part is also equals to this, okay? Should also equals to this numerically, okay? And also similarly over here at this ground level, the EK should be equals to the total energy, okay? That is basically shown by this equation, okay? And the magnitude should equal to what? It should equal to mg delta H, right? So you can use this relation to find out the speed at which it hits the ground, right? So you know EK is equals to basically half mv square. So you can use this equation to also find the speed with which it hits the ground, right? So that is how it is stating. Let's say अगर आपके पास initially the energy was 100 joules. Let's say this is 100 joules over here. So throughout the system, this total energy should remain consistent over here. सही है, जहाँ पे ये लोग ये बता रहे हैं that the magnitude would equals to 100 joules over here. So if you know the magnitude, यहाँ पे कैसा आ गया? Okay, I guess it glitched. It glitched here. Strange. Okay. So this is basically equals to half mv square, right? So if you know the magnitude of total energy, you can substitute over here like this, 100 equals to half mv square. So let's say you can also find the speed at which it hits the ground, right? This is just relation of conservation of energy when a ball is getting dropped for a certain height and it hits the ground. Okay. If it is clear, give me a thumbs up.
सर, मुझे ये 100 वाली बात समझ नहीं आई.
100 वाली बात समझ नहीं है? अच्छा, so ये कह रहा है ये है क्या है? Okay, let me see it first. So first of all, जिसको clear है, those people give me a thumbs up. It is clear to Mashal. And what about others? Ruba, Hamza, May.
सर मुझे भी वाली बात समझ नहीं 100 यूज वाली
100 वाली, ठीक है. So basically, I was just saying कि when the ball was basically getting dropped at a certain height m, ठीक है. So at this point, it has only gravitational potential energy, that is mg delta h, right? So that, let's say, was given to you as 100 joules. Let's say example. Okay, so it's an example over here. So throughout the falling of the ball, the total energy should remain 100 joules. Does that make sense? It can be in different forms, but the magnitude should remain to be 100 joules. Does that point make sense?
तो लाइक बेसिकली सर जैसे अगर स्टार्टिंग में 100 थी और कुछ भी कन्वर्जन हो जाए तो आखिर में 100 ही रहेगी
No,
एनर्जी.
it was in
ओके.
between. So the energy was
ओके.
available in two forms. That is, it was a sum of gravitational potential energy plus kinetic energy. But इनका sum भी should equal to 100 joules, right? For the conservation of energy, right? So if you know the initial energy, you can also find the unknowns. Let's say at this scenario when it is hitting the ground, okay, this is the relation over here. ठीक है. So E के अगर आपको, let's say you want to find this speed at which it hits the ground, you can use this relation, right? And you can find this speed over here also. Does that make sense?
सर
Yes.
जो अभी आपने बताया टोटल एनर्जी वाला बीच में, तो हम ऐसे कह सकते हैं कि हाइट उसकी जितनी भी हो, मतलब फॉर एग्जांपल ग्रेविटेशनल पोटेंशियल एनर्जी उसकी जितनी भी हो, मतलब ऑब्वियसली यहाँ की कम हो जाएगी, तो उसकी
Yeah.
काइनेटिक एनर्जी इतनी होगी कि वो 100 जूल्स तक लेके जा रहा है, ऐसा?
Yeah, basically, yeah, that is correct. So let me just write it down more clearly, like you get an idea, right? Let me just draw the scenarios. This is the ground over here, and this is the height, okay, at which it was dropped, delta H. This was the mass initially, the ball over here, and the total energy available in the system was only in form of gravitational potential energy, that is equals to mg delta H, okay? Because the kinetic energy over here is 0. Let's say this value given to you, आपने निकाली, you calculate the value, you got 100, right? 100 joules. Let's say the ball is here now. Okay. Now the total energy is available in form of kinetic energy and gravitational potential energy, right? Let's say the values of kinetic energy is 40 and the gravitational potential energy is 60. The sum is again 100 joules, right? Let's say the ball when hits the ground over here the gravitational potential energy is 0 because the height is 0. However, the kinetic energy will always be equal to 100 joules, because over here, if you want to write down the equation of total energy, that is sum of kinetic energy and gravitational potential energy. Since EP is 0 over here, so to make sure that your total energy is 100, the kinetic energy is also equals to 100, right? Due to law of conservation of energy. Okay, so throughout the system, you can see the total energy conserved. That was, it is initially it was 100. In between, it is also 100, but it exists in different forms, but still the value, the sum is 100. At the bottom also, CK it is 100. So energy conserved throughout the falling of the ball, right? Make sense? Okay, so if it is clear, this example is clear, give me a thumbs up. Everyone? Clear to Hamza, clear to Mashal, clear to me. What about is clear to everyone? That's good, right? So you can, आपके क्वेश्चन ऐसे एग्जाम में आते हैं, ठीक है? So initially आपने एनर्जी निकाल ली, then they would say कि let's say at a certain height, it is in between the starting and the ending point, you want to find the kinetic energy, right? So that's how you should solve the question, right? Okay, so I'm saving it. Give me just a couple of minutes. Okay. So next we have an example of pendulum, right? So who knows what is a pendulum? If someone knows what is a pendulum, raise your hand. I guess you might have seen that those in your science labs in your schools. Yeah, what's
But
the
it is G.
pendulum?
सर इट्स लाइक एक पिवट, लाइक एक पॉइंट के साथ एक लगा हुआ होता है एक धागा या वायर या थ्रेड जो भी कह लो, एंड उसके लाइक नीचे एक बॉल लगी हुई होती है छोटी सी, एंड वो स्विंग करती है.
Okay. So anyone else? Can you
चारों से
explain
टाइम एक
the transfer of energy in this pendulum system? How does energy transfers in this pendulum? It is shown over here, but can anyone explain this in briefly in their own words?
Sir, I'll try. Means if you can say जो पेंडुलम जो है वो एक पॉइंट ए पर है, फॉर एग्जांपल अगर उसको हम वो उस पे और उसके पास अभी ऑब्वियसली ग्रेविटेशनल पोटेंशियल एनर्जी होगी बिकॉज वो सरफेस से सर्टेन हाइट पर है। देन व्हेन इट मूव्स तो उसके पास ग्रेविटेशनल पोटेंशियल एनर्जी भी होगी और काइनेटिक एनर्जी भी होगी। तो पॉइंट ए टू पॉइंट बी, देन पॉइंट बी टू पॉइंट ए अगेन एंड टू सी, तो वो इसी तरह जो है वो ट्रांसफर होगा ग्रेविटेशनल पोटेंशियल एनर्जी टू काइनेटिक एनर्जी and then back again.
Okay, that's good. Okay, so for others, for those it is not making sense, let's start from scratch. Let's start from a simple example, right? Let's start from simple scenario. Let's say you have a pendulum in your lab. This is the supporting. Let's say this is the wall. You have the thread, right? The pendulum is here, right? Just draw a good version of pendulum. So what is a pendulum? You basically have a thread and a bob at the bottom. It can be a metal or plastic or any material you have in your lab. Let's say this is your starting point, right? Okay, this is your starting point. Let me label it as O. Okay, O is your reference point. Okay, so it is the point at which the length of the string is basically, it is straight, it is taut, and it is basically resting at this initial position over here, right? So when your pendulum is resting, this is your reference point, right? Okay, so let's say when you swing, when you swing this particular pendulum, right? Let's say you are doing experiment, you take the metal bob and you raise it till here, right? You bring it here, right? Let's say the pendulum is here now. Right? Okay, so now this is position number A, right? Let me just mark the center point over here. Okay, so this is the reference point when the height is 0, right? This is the reference point. Let's say, okay. So what is the height I'm talking about over here? Okay, that is the reference point, right? Let's say we are taking measurements from this particular line, right? So now this particular metal bob has rise up by a certain height, which is, let's say, h1, right? And this is the maximum point, right? Let's say हमने इसको यहाँ से छोड़ा, it basically comes back over here. This is the maximum point of this particular swing. Okay, this is the maximum point. And it goes back and forth, right? It goes from here and it goes here, then it comes back, taken, and so on and so forth. So now the third position of the pendulum will be over here. Okay, it is at the same, let's say I try to make it same, hopefully same, perfect. Okay, this is point C, right? This is again at a certain height, which is h1. It's same, right? This is the maximum height. Okay, so now it comes, it's basically swings between, it goes to A, O, C, and then C, O, A, O, C. Okay, so it goes from A to O to C, and then C to O to A, right? It swings back and forth. Imagine there is no friction, right? There is no air resistance. We are doing an ideal case over here that the pendulum would keep on swinging so on forever, right? Let's say. Achari, so now over here we need to consider what transfer of energy is taking place over here, right? Okay, so again we learned the equation, right? The energy can exist in either gravitational potential energy form or kinetic energy form, right? Or both. Okay, so we have one equation for the total energies of the system, that is total energy of the system is equals to the sum of potential energy and kinetic energy, right? Okay, so this is the starting reference point. So at the reference point you basically have the maximum speed, right? You have the maximum speed. Okay, so over here the pendulum is basically going either here or there depending upon the oscillation with maximum speed v. Okay. Okay, so let's say we have another scenario, which is basically, let's say the pendulum is in between some these points. Let's say it is here. Right, and this height is basically, let's say, h2, right? And at this point, let's say this particular metal has again a height of h2, right? At the maximum positions, the speed becomes 0 meter per second, right? At the maximum point, the speed is 0. Why is that? Can you explain that when the pendulum reaches maximum point, it almost becomes stationary, right? For a moment. Why is that? Have you seen a pendulum swinging? Have you ever seen a pendulum swinging? Anyone?
Yes.
So when you
Yes, sir.
basically oscillate the pendulum, यहाँ पे आके it almost basically stops, right? Because it had to come, it needs to come back, right? And as soon as it comes over here, it again almost becomes stationary for a very few milliseconds, and it comes back, right? So at the maximum height, it becomes stationary, right? Instantaneous stationary हो जाता है, to basically come back. ठीक है? So these are the scenarios which we have at the maximum points and at the starting point, reference point, right? So at reference point, you have speed equals to maximum over here, right? From simply seeing these values and scenarios, what do you think would be the form of energy available at maximum points? So at maximum point, the pendulum ball moves up by a height of h1, right? Which you can see over here, right? Similarly, on the maximum point, it goes by a height of h1 from the reference point, but the speed at maximum point is 0. So what sort of energy would be available at point A and C?
Sir, gravitational potential energy.
Yes, so it will be basically gravitational potential energy at max point, right? So energy over here is only EP. Okay, so at max point, you have only energy in forms of EP, right? What about at this particular point? When you have at the reference point over here, when your height is basically 0 because that is your reference point. Okay, but you have the speed to be maximum, right? So what would be the state of energy at this particular position, the reference point?
Kinetic energy.
It would be only kinetic energy, right? So that I hope makes sense, right? So this is the conversion, right? So you can see okay, if I go from A to O, the kinetic at A it has basically gravitational potential energy, and at point O it has kinetic energy, right? So it goes from gravitational potential energy to kinetic energy, and if I go from O to C again, the kinetic energy converts into gravitational potential energy, right? Similarly, if I go from C to A, the gravitational potential energy converts into kinetic energy, and then it converts back to gravitational potential energy, right? So it swings back and forth, right? What about the midpoints? What about the points that are in between, like this, which also has certain
They
height?
will have both kinetic energy and gravitational potential
Yeah,
energy.
okay, so it has also certain speed, let's say V1. It also has certain speed, let's say V1, right? So at these instances, let me label this as, let's say, EF. So at EF, the total energy would be in form of the following. The total energy is available in form of both the sum of gravitational potential energy plus kinetic energy, right? So that's how the energy transfer takes place, right? Does that make sense? If it does make sense, give me a thumbs up. Makes sense to Ruba, Mashal, Varda, Hamza, and Maeve. Okay, makes sense to Maeve also. Hamza, समझ आया? Okay, so that is the entire, yes, Hamza. Was there any question? I guess no. Okay. So this was entirely written over here. So at the maximum points, you have only gravitational potential energy. Okay. At the reference point, you only have kinetic energy. At points which are in between the maximum and the reference point, you have both of them, right? So just remember this. Total energy is basically gravitational potential energy plus kinetic energy, right? So at maximum points, you have this to be 0. Okay. And at reference point, at the center point, you have gravitational potential energy to be 0. Okay. At in between, you have basically both of them. Okay. But the magnitude remains same. Okay. Let's say अगर 100 है at maximum point. Let's say if it is 100 here, 100 joules, it should be 100 joules here, it should be 100 joules here, it should be 100 joules here, it should be 100 joules here. Right? So your question will mention that the losses are minimal, or let's say there is no air resistance. That means you can apply the conservation of energy law. Okay. So you consider losses in your A levels. So okay, so you can wait till then. Okay. So in O level you don't need to consider losses over here, right? So we just learned simple cases. When we have learned simple cases at a good level, we can apply complexity also. Okay, we can add complexities. Okay, so now if it is clear, Jalli say it's not homework now, it's class work. You don't do homework. Start this question. You have 3 minutes to solve it out. It's the example of, let me just save it. a boulder, right? Sort of a huge rock is getting dropped, right? So you're just dropping a boulder, okay, from the top of a cliff. So you just want to find, and you want to use the example which we have done for this over here in this particular slide. Okay, so we have done the example for the dropping of a ball, right? So imagine the ball is now a boulder, that is a huge rock. Okay, you're just dropping this at from the top of the cliff, and it is hitting the bottom of this cliff, that is the beach, right? So you just want to find out some things which are given over here. So this would be a good reference which we have done, right? We have done this example in detail, so this will be used in your question. Okay? So that's how you apply your understanding in questions. So start this. You have 3 minutes. I'm going to draw the diagram over here. So let me just draw a realistic picture. Let me just draw the first of all. This is the section for the diagram. And you have, let's say, this is your cliff. And this is your beach. So you have a mass of boulder of 4 kg, which basically rolls over of a cliff and reaches the. Imagine the cliff is almost straight. Okay, let me just draw it a straight one ताकि you don't have issues सर इसमें angle आ रहा है. Just a straight cliff. So a boulder is getting dropped from here. Let's say this is the reference point. The boulder is getting dropped from here. Okay, and it is at a certain height, h. Okay, so you want to just solve this question over here. You have 3 minutes. When you're done, raise your hands. Okay. So we have you. Acha, we have some chats over here which I didn't read. Sir, IT's moments and momentum ends. Hamza, was it clear? Which you asked. Sir, its momentum ends. Okay, it's clear. Take it. Okay, guys, meeting is about to end. Kindly rejoin. We have a minute in the meeting. Okay, Jay, I believe everyone is done. So let's do it together now. And those who are doing it correctly can match the answer, right? Okay, so this is pretty simple, right? So I believe the example was pretty clear, and this is just an application of the example, right? Let me just choose a red color. So you have a boulder of mass 4 kg, right? It rolls over a cliff and it is the velocity of 20 meter per second as it hits the basically the beach, right? The bottom of the beach. So initially the mass is basically 4 kg, right? It remains same. So at it hits the particular bottom of the beach, so the speed with which it hits is given to you, that is 20 meter per second. So at part A, they're asking you to first of all find the kinetic energy with which it lands and hit the bottom of the beach. That is pretty simple, right? How do you find kinetic energy? It is half mv square, right? Just put in the values. So your mass is 4, your speed is 20. So 20 square is 400, 400 divided by 2 is 200, 200 divided by 5 times 4 is 800. So it's 800 joules, right? So now let's go for part B. Part B is saying that what would be the gravitational potential energy when the boulder was about to be dropped, right? So now we have seen this in the example that total energy is basically what? It is equals to sum of kinetic energy and gravitational potential energy. At the bottom of the cliff, when it was basically hitting the bottom of the beach, we found out that total energy was equals to what? Only kinetic energy, right? That was equals to 800 joules, right? So this is at the bottom of the beach. So from this particular example, you have found out the total energy of the system should be equals to basically 800 joules, right? So since we are following the conservation of law of energy, the total energy throughout the fall of the boulder should remain consistent. That is, total energy over here should also be 800 joules, right? So therefore, by using law of conservation of energy, you should always write the statement, right? Law of conservation of energy. So energy, total energy is basically equals to 800 joules, and at top it is only existing in form of gravitational potential energy. Therefore, at the top, your the gravitational potential energy is equals to what? 800 joules, right? That is your answer. Okay, ji. So now the last part is here. Now they're saying that since you know now the gravitational potential energy of the system, can you find edge, right? What is the height of the cliff above which it was dropped, right? That is pretty simple. So now you know EP, your gravitational potential energy is 800 joules. So you just need to use the formula, right? So EP is basically equals to mgh. So your gravity value depends upon your board. If it is IGCSE, use 9.8. If it is GCE, it use 10. So in we are following the book, which is basically IGCSE, so it should be 9.8 Newton per kg. Okay, so the value is written in your formula sheet, right? So in your first page, you will have your formula sheet. Entirely refer to the formula sheet and does confirm okay, what is the value for gravity, right? Let me just use yellow color. It's pretty dark, right? So now let's put in the form value in the formula and get the height. So 800 equals to the mass is 4, the gravity is 9.8, okay, and the height is h. That is unknown. So how do you make h subject? These are multiplying over here, and over there they would all divide, right? So it's going to be 800 divided by 4 into 9.8. Okay, therefore your height is coming out to be something in meters. That should be your answer. Let me just calculate this. So it's 800 divided by 4 into 9.8. So it's coming out to be 20.41, right? 20.41. You always write your answer in three significant figures, right? Always use three as well. So this rounds off to what? 20.4, right? Meters. That is the answer. If everyone's answer was matching, give me a thumbs up. Okay, Mashal got the same answers, Ruba got the same answers, and Hamza and Maeve, everyone got the same answer. That's good, right? That's good. That means the example was clear to you guys. Okay, just the last thing, then we'll end the class. That is work, right? So we had defined work informally. So now we want to define work formally, right? So what is work? Can you explain what is work?
So can I?
Yeah, sure, Ruba.
When force is applied on an object and the object covers distance in the direction of the force, it is said to be work done.
Okay, imagine you're holding a pair of books on your hands, okay, and you're not moving anywhere, right? You're just holding them. So after some, let's say 30 minutes, your muscles become sore, right? So are you doing any work in that case?
No, sir.
No, because it has no direction, sir. Like हम हिला नहीं रहे books को.
Okay, it has no direction. What about Mashal?
Yes, sir, because the force is not moving, so we cannot say it is in work.
But why are our muscles getting sore?
Because of
Because
the
the force that is
gravitational.
being
Raise
exerted.
your hand and answer. Yes, Varda.
Sir, I was saying because of the gravitational field strength, it's pulling the like force जो हो रही है वो downward वो करती है ना effect. So उसकी
So
वजह से आपको strain आ जाता है.
what about Ruba?
So I was saying the same thing that the force is being exerted on the hand, so that's why it's getting sore.
Okay, Mashal, you want to add something?
Sir, it's same.
It's same, sir. ठीक है, sir, same option. Okay, good. ठीक है. Yeah, so that is interesting point, right? So here this is the point where people get lost, right? Okay, first of all, what is work done? Again, we have discovered this, right? Let's imagine you are standing over here, you have a block of mass, right? Let's say here is Maeve, right? Maeve is standing over here. Maeve wants to move. Let me just make a capital M just to differentiate Maeve and mass. Here is Maeve over here. She wants to basically push this box over here. So she applies the force F, and the box also move in this direction. That is by a distance T, right? So Maeve is doing this scenario is basically Maeve is doing work done, right? So now imagine this scenario. This is scenario A. Imagine scenario number B. Okay, let's imagine here we have Varda. Varda is holding, let's say, a pair of books. Let's say like this. Okay. So she's standing over here. She's applying a force in this direction, right? To basically keep the book steady. And because the weight of the books are here, okay, towards the center of the earth. But there is no distance travel, right? So distance travel is zero over here, right? So what do you think? Are we doing work done in A? Yes or no? Are we doing what
Yes.
case A? Watch out. Whoever is saying yes, give me a thumbs up. In case A, we are doing work done. Okay. So everyone except Mashal, everyone is saying case work done, right? So yeah, it is work done, right? What about case B? Are we doing any work done? If anyone thinks in case B we are doing work done, give me a thumbs up. Okay. Okay, no one does. Okay. So yeah, this is not an example of work done. Okay. So this is not an example of work. So this is pretty important. Why? Because distance is not travel and okay. So there is no distance travel in the direction of the force applied, right? So the force our muscle applying over here is basically upwards, but there is no distance that thing which is getting travel, right? Why are muscle getting sold over here? Imagine these are muscles over here, right? Imagine these are muscles. Okay, so they are constantly giving a force in this direction, right? They're giving you, they're working out to give you a force in this direction. However, they also have to basically compensate the weight, right? To compensate the weight of the box, they want to stabilize this, right? So to stabilize this particular component, they are applying a force in upward direction. That is the reason that your muscle gets sore, right? Okay. So let's quickly go through the content. So in energy transfer, work is done, right? So the work done is a major amount of energy transferred because let's say the when Maeve is basically trying to push this particular box, the Maeve has chemical energy in her body. She applies the force, okay, and that field basically leads to kinetic energy because the box starts to move at a certain speed, and it has basically converted the Maeve converted her chemical energy into kinetic energy, right? So that is again a transfer of energy that is called work done, right? Same amount of mechanical, sorry, let me use a highlighter. The same amount of mechanical or electrical work is done by transferring amounts of energy over here, right? So mechanical work is done when a force moves, right? So this is example of mechanical work, right? Why mechanical? Because mechanical can then we have a force which is driving something and it causes something to move, right? So we are driving a block of mass m and it is driving the block of mass m by distance d, right? So this is called mechanical work, right? Electrical work क्या होता है? Let's say if we are driving a charge in an electrical circuit, right? Let's say we have a circuit over here which we study in the circuits. So let's say if this is a battery over here, this is driving electrons, right, in this direction. Okay, so it is electrical work. This is very important. No work is done in any scientific sense if someone is standing still holding a heavy pile of books. Okay, okay, so there is no motion resulting over here. So there is no work done in this case over here, right? Okay, so how do we calculate work? It's pretty simple, right? If you have a mass m, right, and if you apply a force F, and the same mass covers the distance in the same direction, that is d, so you can calculate work done by simply doing force into the distance traveled in the same direction, right? What about its SI unit? You can see that force is measured in newtons and distance is measured in meters. So work done SI unit is basically what it is, Newton meter. Okay, or it is also same as joules, right? Because it is, since it is energy transfer, it is also labeled as joule sometime, right? Either way is correct, right? Okay, so again, this is the formal definition over here. The work done is equals to force and to distance, but it moved in the same direction as the force. The joule is basically same as Newton meter. Acha, if I ask a question in your exam, there is a question in theory. Okay, what is joule? Right? What is joule? So what is joule? Can anyone answer this? What is
Can I?
joule? Yeah, sure. Rupa.
When 1 Newton forces acts on an object and the object covers a distance of 1 meter, it is said to be 1 joule.
Yeah, good. Okay, so whenever you have a question like this, what is joule? Let's say what is watt? Okay, WATT, power wala watt. Or let's say what is coulomb? Okay, so whatever question pops like this, so always refer to its formula, right? So for joule, let's say you just refer to the formula. Okay, so now the formula is F into D, and the left side is joules. Okay, and the right side is Newton meter, right? So if I say okay, what is 1 joule? So 1 joule will be basically when you have 1 Newton times 1 meter, right? So this is the definition of joule over here. So 1 joule is when a force of 1 Newton is applied and the object moves by and the object moves by 1 meter in the same direction, right? So I'm not writing that, so I don't have space. This is how to define joule over here, right? So we have discussed this formula unofficially in the start to derive gravitational potential energy, but we are doing this officially over here with everything with every detail over here, right? Actually, so then we have a small example, then we'll end, right? So again, a small example है, that is as follows. La 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 save हो जाओ जल्दी से. It's saved. Yeah. So we have examples over here. I would want you guys to solve this. This is example A. This is example B. So solve example A right now. So listen. Want to find the burden. Okay, you have a mass of, let's say, M. Okay, and this is the starting point. This is the ending point. S E. Want to find the burden done on this particular box of mass M. Let me know if you're done.
Sir, I'm done.
Okay, good. Just raise your hand, whoever is done. Okay, Hamza, Mashal, Ruba are done. We are waiting for the others. Varda is also done. Okay, so anyone left is May done. Okay, I guess everyone is done. Okay. So let's continue and let's end after this. So we have the case A, which is pretty simple. Okay, this is the F over here. This is the distance traveled in the same direction. You can see that they are parallel, right? So they are parallel. You can see the distance and force are parallel. Therefore, you can use the distance finally. So what is the formula for burden? It is force into distance, right? Distance travel in the same direction. Right? So therefore, you can see the force and the distance are in the same direction because they are parallel to each other. You simply multiply them, right? So it's 50 into 3, right? So your work done comes out to be 150 joules or Newton meter. Right? Either way is correct. What about case B? Case B can the person basically lifts the block of mass 3 kg vertically upwards, right? So this is the force applied by the person and this is the direction of the distance traveled up, right? So what formula can I apply over here? Work done, right? Again, work done is equals to what? FD, right? We see if we have this sort of scenario, we basically have gravitational potential energy over here, right? So usually work done is same as energy. So this can be calculated using the formula for gravitational potential energy. We have derived this before, right? Because FD हमने use करा. So F is what? It's the weight of the block. So your work done will be equals to mg, that is the weight, times the distance traveled, that is the height. Okay. Just apply your formula. You get your answer. That is going to be 3 into gravity, 9.8 for IGCSE. For GC, it's 10 times height, which is basically by which it is lifted up. Just get your answer. So it's 6 into 9.8. That should be around 60. So it's 58.8, right? 58.8 joules or Newton meter. Either way is correct. That is the answer, right? Does that make sense? If it does make sense, give me a thumbs up. I have a raised hand from Hum. So now we have a new section over here that is energy resources, right? So we have talked about how can you do work, right? But how can we produce energy is the question over here, right? Okay, we have, let's imagine you have your houses, right? Imagine, let me just draw some diagrams over here. Okay, so let me just draw some diagram over here. This is, let's say, ground over here, and you have, let's say, a power supply. Okay, it's a pole over here. So, okay, and imagine, okay, this is a station over here. It's a power plant, right? It is producing electricity, right? From here, electricity comes through wires, okay, and through basically transmission lines, it comes to our houses, right? Let's imagine this is our houses. It comes to our houses, right? Okay, so this is basically one form of the entire process. Okay, these are called transmission lines. These are called transmission lines, which are cable, right? Through which energy is being transferred, right? Acha, so now the main question is, what is happening over here, right? What is happening over here? That how is this particular thing producing electricity, right? Right? That the question is, how are we, how are we producing, how are we producing electricity, right? So through what methods can we produce electricity, right? Power plant means it produces power, right? So power is basically, and what is power? We'll discuss this in a while, right? So power, energy are interlinked together. So This particular power plant produces electricity, right? So how does it produce electricity? That is the main question over here. How can we produce electricity, right? So at this point, I would like you guys to pause the video and think about the processes, right, through which we can produce electricity. What are those? Think about it, right? Okay. I believe you have thought about the processes, and I believe you might have come across some processes which will come into the slides in a while, and you will basically make it will make sense ke how is it basically working, right? We will dive not too deep, but in a breathwise, we will just try to understand ke how does the overall system works. If something does not make sense, it's a recording. You can always go back and replay, right? Okay. So again, we had different types of energy resources, right? So we have two types mainly. So the first one is called renewable, right? The renewable energy source, the renewable energy resource, and the second one is called non-renewable energy resource, right? So through which we can produce this, we basically produce electricity, right? Non-renewable energy resource, right? Okay, so again, the content is also saying the same thing, right? You can have different types of energy sources that is basically renewable or non-renewable, right? So non-renewable resources basically, let me just highlight this correctly. Yeah. So non-renewable sources present previously stored energy, right? We have seen basically some examples which basically had covered non-renewable examples over there, but we will see some more examples over here. You connect them together in a while, right? Okay. Again, they are starting. Acha, first of all, let me define okay, what is renewable and what is non-renewable, right? So it makes sense to you guys. Okay, what are we talking about over here, right? So first of all, we have non-renewable, right? We have non-renewable energy sources. Energy resources. Okay, so what if I question comes in exam, okay, what is meant by non-renewable energy resources? So you can just write this definition over here. The resources which cannot be replenished replenished after use. Alright, and let me show you the meaning of replenished. What does replenish means? Replenish. Okay, right, fill up again. ठीक है, stop a form or something over, right? So replenish link with non-renewable. I even more sense now. Renewable resources. So difference between these two types of resources is that one can actually replenish themselves while non-renewable cannot, right? So what does replenish means? Here it can reproduce itself, right? Let's say if I talk about solar, if I talk about hydroelectric power, right, there is water, okay, water is free. Sun, there is sun is always there, right? It will be there for millions of years, so it can basically, we can have sun basically free, right? That particular source of energy would be there, right? Would be there forever and ever until and unless basically this universe is alive, right? So non-renewable are basically fossil fuels. They're crude oil, they're coal, right? And you know, okay, after some thousands of years, these particular sources will die off, will vanish, right? Why? Because we had dinosaurs, right? So it is for what are fossil fuels? If I just talk about fossil fuels, what are fossil fuels? I would like you guys to think about it. Pause the video, think about this. What are fossil fuels, right? So basically, these are the remains of dinosaurs, right? Remains of dinosaurs or basically animals. Mostly dinosaurs because they had huge skulls. So dinosaurs were there thousands of years ago, right? And when the asteroid struck the entire Earth, right? What happened? The what happened basically? What happened is that okay, the bones of the dinosaurs went beneath the sand, right? The bones went over here. The bones went on, keep on going towards the bottom of the layer of the sands. And when they basically reached the core, basically the upper core, they started converting into coal and then steam and basically and then fossil fuels and different forms of fuel which we have currently over here, natural gas, so on and so forth, right? Crude oil. So again, obviously, dinosaurs were not infinite, right? They were countable, right? They are finite. There were finite number of dinosaurs, right? Obviously, they were in huge quantities, but again, they had some basically countable number of bones, right? There were not infinite number of dinosaurs already. So obviously, the remains have been getting utilized till now. We are fueling up cars or bikes, jets. Okay, we are basically making roads. We are using crude oil everywhere. Okay, so it's going to end, right? So that is what we're concerned right now. So these are basically called non-renewable energy sources, right? We will discuss some methods over here and of production of energy through non-renewable and renewable. And we'll compare the benefits and drawbacks, right? Why is that process helpful, right? Why is the process used? You're surprised to know, okay, what process are we using right now for producing electricity, mostly in Pakistan, most approximately all around the world, right? Okay, so then renewable energy sources, right? We have renewable energy resource, right? So what is that? So these are basically just the opposite of non-renewable. So the resource which can replenish themselves, which can be replenished, right? After use, right? So like sun, we have sun can basically sunlight can be there forever and ever. Right? It will not vanish off until and unless the universe collapse, right? So these are basically the two definitions of sources, right? Okay, so we are just basically thinking about some benefits, right? So non-renewable के अंदर क्या क्या आता है हमारे पास? We have this, right? We have crude oil. We have crude oil over here. We have fossil fuels. Fossil fuels. We have coal, right? We have coal, right? And if we basically do fractional distillation of crude oil, we get different components, right? We get basically kerosene, tar, and so on and so forth, right? So these are all non-renewable energy sources, right? So anything which needs to be burned, right? All sorts of fossil fuels, coal, basically needs to be burned, right? And what happened to my coal spelling? Let me fix it. It's coal, right? It's coal, right? So whatever these sources are, they all need to combust, right? So what is combustion? Because basically you burn them in oxygen and they basically produce carbon dioxide, right? Again, benefits. What are the benefits of this, right? They have high energy density, right? They have high energy density, right? And they are basically readily available over here because we can find coal, roasted fuel, and petrol under basic surfaces. Mostly the crude oil is basically mostly found in Gulf countries, okay, Gulf states, that is Saudi Arab, yeah. So that has very huge oil pipelines over there, right? They have huge sources of oil, petrol, and crude oil, fossil fuels, right? So and what is meant by high energy density, right? That is, they are pretty concentrated, right? You can just think about the density. What is density, by the way? Density is mass upon volume, right? So if I have high density, that means that is, let's say, if I compare this is a cube over here, right? Let's say if I fill the entire cube with huge, basically large number of atoms, many number of atoms of basically fossil fuels or coal in a very small volume, right? That means it has high energy density. So if we burn small amount of let's say high energy density, let's say like coal, okay, it will produce huge amount of energy, right? So that is the benefit over here. Okay, let's say, let's imagine one mass. See, let me just write 1 kg. So my Zoom is dying. Let me just open my hotspot. Okay, so let's continue and let's start from where we left off, right? We talked about energy density, right? So just imagine a huge amount of number of atoms are basically fixed inside a small volume. So it's high dense, right? So if you burn, I will just give you an example over here, right? So if you burn, let me just choose this. So if you burn, let's say 1 gram of let's say that particular, let's say carbon, you get let's say 1,000 joules, right? 10,000 joules. So that's huge, right? That's huge. The 1 gram is giving that much amount of energy. So that is the benefit, right? So the coal is basically contains huge amount of carbon in a certain small volume. So it is pretty high dense, right? That and if you burn that, it produces huge amount of energy, right? And the benefit is that it's pretty much available, right? So we have huge remains of fossil fuels throughout the world, and we can find them pretty much easily, right? So the availability is simple, right? We don't have to hunt huge number of kilometers to basically find the remains. So it is that case we can find resources easily, right? You can find resources easily. That is the benefit of it, right? I hope it makes sense. If you have any questions, you can just first of all start to, you can just rewatch this part, or you can, if you have further questions, then you can text me privately, right? Okay, so the first of all we have the fossil fuel, right? So fossil fuel से क्या होता है मुराद? Fossil fuels basically the remains of dinosaur, right? Let me make some dinosaur. Let me make a dinosaur. Okay, so let me make a dinosaur. Oh, it is a dinosaur. Believe me that it's a dinosaur, right? It is a dinosaur, and it has 4 legs, hopefully, and a tail, right? So the remains when they died, right? They were asteroid hit the earth. Then the bones came beneath the surface of the sand, and these basically remains are basically named as fossil fuels. Right? So it has multiple branches, as it is written over here. Fossil fuels के अंदर we have coal, oil, natural gas, right? So which are basically remains of plants and animals, right? Also plants. But plants don't contribute that much as compared to animals because the bones, our average human being bones also contain huge amount of carbon, right? So the bones contribute the huge chunk of this particular fossil fuels. Plants are also there, right? So plants die off after many hundreds of years, right? So the ratio is small compared to animal, right? Okay, so they used to live millions of years ago, right? And again, they obtain the energy from sun, right? So obviously, when the plant needs sun to grow, right? Sunlight. So, and animals also need, all animals eat plants and also basically need sunlight to survive. Right? So everything was coming. Means imagine the sun was the source of energy, right? For them also. Now the energy is stored as chemical energy, right? And they're basically the main energy source over here. So fossil fuels, right? So what happened again? Chemical, right? Carbon is one of the chemical formula over here. It is carbon, right? So those remains basically are stored beneath the layers of the sand, and when they are basically under pressure and heat for millions of years, and they become fossil fuel, right? So, so again, what is the drawback, right? What are you concerned about, right? Okay, it's going to end, right? It's going to end. What is the concern over here? What is the concern over here? That since it is non-renewable, it is going to end. It is going to end, right? And obviously, you can just imagine the current world, right? Every power production on in Pakistan, maximum around all the world, is basically on coal. Right? Just imagine when coal is not there, right? Imagine the trains which are running coal, right? The steam engines. Imagine cars, bikes which are running on petrol, right? Which again comes from fossil fuels. Imagine okay, if they are not left. So how would bikes, cars, electricity, right, motors, power plants, industries would work? Right? That is the main concern over here, right? So what is the prediction over here? So predictions vary as to how long they will last, how long they will last, okay, and what reserves are recoverable, what we can basically again recover, and on the future demands of a world population, okay, it is going to increase from 7,700 million in 2019 to 9,700 million, right? So demand for fuels is going to increase by 2,000 million, okay, from 2019 to 2050, right? That's a huge increment, right? So demand is increasing. Fossil fuels are again at a fixed amount, right? They are not also increasing, right? They have been formed millions of years ago, and they are not basically forming or they are not reproducing themselves, right? So both hey, dinosaurs they died, they formed that basic current amount of fossil fuels, and obviously we are just utilizing it, right? The demand is increasing, but the supply is not, right? So obviously it's going to exhaust. That is why it is non-renewable, right? So some estimates say that oil and gas will run low early in the present century, but coal should last for 200 years or so because coal is again just carbon, right? Just chunk of huge chunks of carbon. And natural gas and oil, basically, what happens when the fossil fuels are under extreme heat and pressure, right? So the bones basically vaporize, right? When they vaporize, they form different forms of fossil fuel, that is oil and gas, right? So obviously, it is going to end much faster. Why? Let's imagine this. This is the Earth's surface. This is the Earth's surface over here. This is the Earth's surface, or you can say crust, not land. This is the crust over here. And let's say these are layers, different layers, right? So at the top layer we have gas, right? Then we have liquid, and then we have solid fossil fuel, right? Because of, depending upon the density, right? Gas has the least density, so it has it, right? So natural gas can be just be extracted out of the Earth's surface by just putting up a pipe, right? If you just put a pipe, the gas comes seeping out, right? Like this. You can just collect the gas and again process it and refine it and then sell it, right? So that is fossil fuel, right? This is one of the non-renewable energy sources, right? So we are now all talking about non-renewable energy sources. What is the benefit of that? Again, it has high energy density. If you burn coal, you're gonna get huge amount of energy, right? And instantly, right? It is available throughout the area, throughout the land, right? At the moment, since it has not exhausted yet, but depending upon the demand, which we saw the pattern from 2019 to 2020, 2050, is increasing rapidly, right? It's increasing rapidly, and the resources are fixed, so it's going to exhaust after some time, right? Then we have nuclear fuel, right? So nuclear fuels के ऊपर हम बात करेंगे chapter number 5.1 in detail, right? So that is where we talk about fusion, how is energy produced over there, what is chain reaction, right? We talk about this in chapter 5.1, okay, which is part of your syllabus, so don't worry about this. So just skim it, right? So what happens? Fission, basically, we'll see what is fission, right? So imagine just, okay, we have an atom. After the process, this becomes two small atom, right? And it also produces a huge amount of energy as a byproduct. Because it's sort of a byproduct in the process over here, right? Okay, so again, this particular energy can be used to produce electricity, right? Again, the benefit of nuclear fuel is that they do not pollute the atmosphere, right? So they don't produce carbon dioxide or sulfur dioxide. Right? That is the main reason which causes global warming, and it basically depletes the ozone layer, right? However, they do generate radioactive waste, right? Let's say अगर आपने radioactive waste, let's say you have a industry over here, you have a nuclear power plant over here, you have a nuclear power plant here, nuclear power plant here, right? And then let's say we have a reservoir over here, right? Let's say we have a lake over here, we have a lake over here, right? So what happened? What happens? Let's say the waste goes through the industry over through here, right? So over here, let's imagine if there are fishes over here, and you're just disposing of radioactive substance in the lake, right? Radioactive. Okay. Marie Curie, if you remember Marie Curie, she was a scientist. She was the only female scientist who got two Nobel Prizes, right? She died of radioactivity, right? Because she was exposed to radiations way too much. Because at that time she was discovering radioactivity. We didn't know about the drawbacks of the basically the harms of radiation, right? So imagine the fishes being exposed to radiation, right? They can kill thousands of them, right? Okay. Again, as long as the reactor is operating normally, right? It does not pose any radiation risk, right? But it is pretty, you can say, sensitive process, right? If any leak occurs, if any accident occurs, right, the explosion is huge, right? Just imagine fission, right? Fission, we will see in chapter 5.1 what is fission, right? It goes in chain, right? मतलब ये होता रहेगा, होता रहता है, होता रहता है, होता रहता है. It goes in sort of binary tree, right? Let's say this was the actual element. We did fission, we had two baby products. Okay, we had two small subatoms. Then this again go under chain reaction, they become further smaller, and they become further smaller. And this goes on, right? So it's sort of a chain reaction over here, right? This is a chain reaction. So if basically any accident occurs, this reaction basically speeds up, right? So if you have a nuclear bomb, you just imagine Hiroshima, Nagasaki, the nuclear bomb site. So why did it cause huge destruction? Because it was a chain reaction, right? So it started from single uranium atom, and it basically went in chain and destroyed the entire area of Hiroshima, Nagasaki, right? Okay. So now we are moving on towards renewable energy sources, right? So renewable energy sources क्या होते हैं वह हम पढ़ चुके हैं, right? So इसके अंदर we have different types over here. We have solar energy, right? We have solar energy, we have wind energy, right? We have wind energy, and then we have hydroelectric power, right? Which is HCP, जो हम पढ़ चुके हैं. And then we also have, let me just see what else we have. Solar, we have wind, we have wave energy, tidal, hydroelectric, biofuels, right? So then we have also have wind energy over here, right? Then we have tidal energy over here, right? So again, these all are renewable. Why? Because for this, for solar energy, I need sun, right? It's free, right? It's always there. For wind energy, I need wind, right? I don't need to burn anything. I don't need to take out any. I don't need to dug any ground for that, right? For HCP, I need water, right? It's available in huge quantities. It's free, right? For tidal energy, we need again waves, right? And waves are pretty much common in oceans, right? Again, that's renewable, right? They can replenish themselves. They can reproduce themselves, right? That is why they're renewable, right? Okay, so now let's dive into each part briefly, right? Whatever the content, basically the syllabus is telling you to understand, and that much is enough for you, right? Okay, so we have solar energy, right? So what happens in solar energy, right? Let me just take you to the block level diagram over here, right? Imagine there's a sun. Imagine there's a sun over here, right? And you have a solar panel, right? You have a solar panel over here, right? You have a solar panel over here. You might have seen those in some houses or in some areas. They look like this, right? So there are solar panels over here. Okay, it can be also like this in your home, right? Which are placed just to absorb the sun UV radiation, right? Okay, so what happens? The sunlight hits the solar panel, right? So over here it has basically photovoltaic cells, right? So what do they do? They basically convert the sunlight, right? This is the sunlight over here. They convert the sunlight into basically electricity, right? So they have some sort of, let's imagine we have a battery over here, right? We have battery, right? So what do? They convert the sunlight into electrical energy, right? This is the overall process which is happening over here. So it does not need any generator or any motor over here. Process is pretty simple, right? So we have sunlight, right? Through solar panel, it converts it into electricity, right? So we don't need to understand how is it doing it, but this is the overall. We should just know, okay, what is the overall process over here, right? Okay. So what happens? The energy falling on the earth from the sun is transferred from mostly by visible light, right, and infrared radiation, right? And in an R equals the total energy by the world over, right? So basically, they are just telling you, okay, if I just let's imagine, okay, the world uses, let's imagine, X joules of energy per year, right? So this much of energy is basically transferred by sun in basically only 1 hour, right? Imagine huge amount. This is the amount of energy which is being transferred by the sun to the earth in just 1 hour, right? Okay. But what is the drawback, right? So एक जो होता है हमारे पास, it is sort of a grid over here, right? It's sort of a grid like this. It's sort of a grid like this. Let me just show the grid. It's sort of this. Ta-da, ta-da. Okay, so this is the grid over here. You can see the solar panel also, right? And just see this. But I'm trying to replicate this, right? So what is the drawback of this? If I just see this particular single PV photovoltaic cell over here, right? So it only produces a maximum of 5 volt, right? So the voltage produced by each solar cell is pretty small, right? So you cannot generate huge amount of voltage. Uh, so the energy density is low. Okay, so you can just see that it is producing less energy by collecting as compared to other sources, right? So it is low energy density, right? It requires large collecting devices, right? You can see that if you have a solar pura entire power plant, it will have huge area, right? It will need huge area and a lot of amount of solar panels just to produce an energy which is produced by a small coal burning power plant, right? So that is the drawback over it. Okay, so let's continue, right? Okay, so again we have seen that, right? What is the scenario of low energy density over here, right? Again, what is the potential use of basically is that it can basically work on low temperature water heating, right? So again, it can work as this here, potential gas can be energy source for low temperature water heating, right? So imagine if you want a moderate heating system for your water. So solar energy will provide enough energy for basically heating up your water because it will provide enough energy, right? Which can make your water to a certain temperature. But if you want to produce power, let's say if you want to support an entire city with electricity, that would be difficult with solar energy. But if you have huge area which you can dedicate for entire solar panels like this, so you can use basically we'll have to use a huge number of power panels, and that would be enough to basically produce, let's say, to support X number of houses, right? The energy transferred by electromagnetic waves from the sun is stored as internal energy in solar panels and can be transferred by heating to produce domestic hot water at about 70 Celsius to heat swimming pool, right? They're just telling you the benefit, right? Okay, let's say if you want to adopt the solar panel system, so you can start from just heating your water, right? Of swimming pools, right? Okay. So the next in line we have the wind energy, right? So again, what is wind energy? So if you might have seen windmills, so these are sort of state power poles over here, right? And over here it has wings like this. Right? It's not a flower, it's a windmill, right? So what happens as the air blows, right? This particular turbine moves. Okay. So this is called wind turbine, right? This is called wind turbine. And the process is pretty similar to the basically the coal power plant, right? Which we have seen. So what happens as soon as the wind moves the blades, the wind turbine, right? It produces mechanical energy, right? So it is linked with basically a generator, right? You have seen this before also. It is linked with a generator which basically produces electrical energy, and basically these are going through wires to homes, right? So this is basically how the energy is produced. Let me just again draw a block diagram. So you have first of all you have a wind turbine, right? And basically this goes to the generator, right? This goes to generator. So the wind turbine is producing mechanical energy, and the generator is basically converting mechanical energy into electrical energy, right? This is how it is pretty simple, right, to operate a wind turbine. Okay, so now let's move on to the next part. Okay, so you can see that these are how wind farms look like. Okay, and this is pretty, you can say, aesthetic. But again, the drawback is that it occupies huge space, right? You will need, if you just go and visit this physically, they are huge, right? The blades are huge. So it needs huge spaces to be built upon, right? So first of all, let's read the content what is available over here. So again, infrared radiation from the sun is also responsible for generating wind because wind is again produced by the rays, okay? Because they create pressure in the air through heating it, and these basically produces winds, right? So giant windmills called wind turbines with two or three plates, each up to 30-meter long, okay? Drive electrical generator, right? 30 meter is a huge number. Just search 30 meter, right? It has 30-meter wings, right? The wings blades. Okay. If a wind farms of 20 to 100 turbines space about 400 meter apart, right? Supply up to 400 megawatt, enough electricity to basically support 250,000 homes in the UK, right? So it has the example, the picture over here has basically how many? It has 100 turbines, right? So 100 such windmills put place across this entire region. and it can produce 400 megawatt, right? That's huge. That's huge. Right. So I went to basically K Electric power plant that is in Bin Qasim. So I basically visited Bin Qasim station, Bin Qasim power plant, Bin Qasim power station, right? And they basically uske andar they had three power stations over there. BKPSP1, BKPS2, BS3, right? So they were producing, according to me, if I remember, it was 520 megawatt, and it was basically then 640 megawatt something, and then it was 960 megawatt, right? So these all are basically coal powered, right? They are all coal powered, right? Coal or basically fossil fuel. Okay, so they were using basically fossil fuels over here. Okay, it is powered by fossil fuels, right? So just imagine this, okay, since they are huge, they are high energy dense. They are also producing at around 520 megawatts, 640 megawatts, right? But if you place 100 turbines, okay, they are also producing 400 megawatt. But what is the drawback? It needs 400 meters separation, right, between just two turbine farms. So it's just between two wind turbines, right? Imagine the space which basically will be required for placing the entire wind turbines over there, right? So again, they are noisy, right? Because when they spin, they produce noise, right? Because of air resistance and air crossing through the winds, sorry, the wind turbines and the blades. So it produces noise, okay? And again, environmental not friendly because you have to remove, let's say, cut the trees and let's say remove the houses which are in the location where you want to place your wind turbines. Again, it disrupts the great natural beauty, right? So now you're starting with wave energy, right? So what does wave energy means? Can you explain? How will I basically use wave energy and what would it produce again? Can anyone explain? Just guess, okay, what will be wave energy? If anyone wants to guess, give me a raise of hand. So basically, imagine this, okay, you have, let's say, it's a sea over here, right? Let me just make a sea over here. So you have a sea over here. Let's say these are seas and these are waves, right? Let's say these are waves, right? And over here we have turbines placed like this, and inside underwater, right? We have huge turbines placed over here. Right? Let's say we have turbines over here placed, and then we have turbines placed over here. Now just seeing this diagram, and the water is flowing like this. Okay, the water is flowing like this. So now just seeing this particular setup over here, can anyone try to explain okay, how would this particular process or setup will be producing electricity? And this is the land, right? This is the land. Yes. Anyone wants to guess? Give me a guess. It can be wrong, correct? I don't care.
सर क्वेश्चन क्या था?
I'm just saying कि we have wave energy. Can you explain how is wave energy producing electricity? इसके अंदर होता क्या है?
सर ये टरबाइंस को मूव करता है जिसके जो जनरेटर से कनेक्टेड होते हैं ना।
Generator से?
जी
Okay, yeah, that's fine. ठीक है. So just imagine any power producing system, right? Any. Let me just summarize. ठीक है. So power, any power production process. ठीक है. Whether it is burning fossil fuels or using solar energy or using wind energy or using tidal energy or using wave energy, right? So what happens, right? You just need a source. You need a source to move the turbine, right? To move the turbine, right? So to move the turbine over here, then it basically does what? It moves basically a turbine. It goes to turbine, right? And then this particular thing connects your generator, right? And this basically energy goes to your houses, right? This goes to your houses, right? So every process is basically this over here. If you just try to relate every process, it will basically be summarized over here, right? So this particular source can be steam, right? This process can be steam. This process can be steam. And let me just tell you the other names over here. Okay. So it can be steam, it can be water, right? In hydroelectric power, we have water, right, which is coming from the top of the dam and we basically moving the turbine, right? Can be steam. In basically coal power station or any basically fossil fuel power station, वहाँ पे हम burn करते हैं fossil fuels को and उससे क्या होती है produce होती है steam, right? So we can have either water or steam which basically moves the turbine, right? And this particular system produces mechanical energy, right? It produces mechanical energy, and then this particular links the generator which produces electrical energy, right? So every any process which is producing energy, whether it is renewable or non-renewable, follow this particular block diagram, right? And this basically is basically transmitted. This is transmitted to your houses or industries or any other location in the city which basically needs electricity to operate, right? This is how the overall process of any power production process works, right? Okay. So just try to link this, learn this particular block diagram. You will find this common in everything, right? So now we're talking about wave energy, right? From wave, what do you get? It's just a wave in an ocean, right? Or a sea. So we want to capture the wave energy out over here, right? So basically the waves are moving over here. So waves, the wave energy को हम convert कर रहे हैं into electrical energy, right? So these waves basically causes the turbines to move, right? The turbines move in this direction, and these turbines are linked to the underwater. Okay, and these wires come out on the land, and this basically again is connected with a generator over here, right? It is connected with a generator over here, which produces again what? Electrical energy, right? So this is one form of renewable energy. Why? Because if you are using just water, right? Water is available throughout the world. It's 75% of the entire earth, right? So it's renewable, right? It will not exhaust until and unless the universe collapses, right? Okay, so that is why it is called renewable. So let's see what is the wave energy from continent. So the rise and fall of the sea wave have to be transferred by some kind of wave energy converter, right? So what is happening? We want to convert the wave energy into electrical energy, which is required by us, right? So what happens? Again, the wave energy causes the turbines move. The turbines cause rotatory motion in the turbine, which produces mechanical energy, and that mechanical energy basically is linked with the generator, which produces what? Electrical energy, right? So that is very simple. So you should know the algorithm. The algorithm is this. Okay. Say we need a source. It can be water, it can be steam, anything, right? So that, but basically will move. It can be wind also, right? It can be wind also for windmill, right? We have seen that in the last lecture. So that's basically that moves the turbine, right? And the turbine basically does what? It basically links the generator. The generator basically produces electrical energy, and that is basically sent to your houses, right? That is the process if you which you basically found in everything, right? Wind turbine, generator, right? Over here, you also saw basic sunlight, electricity, right? So in solar energy, it is basically direct, right? So we convert the direct sunlight to electricity. But apart from this, everything is common, right? If you see over here, we have again nuclear energy, which basically moves turbine, and then which moves the generator, right? And then over here we have fossil fuels, which is again burned. And when they are burned, they produce steam. That steam basically again moves the turbine, and then turbine basically is linked with a generator, which produces energy, right? Electrical energy. Does that make sense? If yes, give me a thumbs up. The general idea of how is electricity produced makes sense to Mashal, Varda. Okay, makes sense to everyone except Hamza. Hamza क्या समझ नहीं आया? Hamza, is it clear?
जी सर.
ठीक है. So again, since it is the wave can be basically. अच्छा, what is the drawback of this? Can anyone tell me the drawback of this?
सर वेव्स सिर्फ दिन में 2 दफा आती हैं.
Yes, that is when.
एवरी 12 आवर्स सर, जब मून की फोर्स है.
Yeah, so basically waves are only produced twice. But the strong waves, I'm talking about strong waves, right? Which can move huge at which can move the entire basically turbines at a very fast rate, right? The maximum energy हमारे पास 2 दफा आएगी. That is basically at 12 hour gap, right? At basically around the midnight, you have basically, I guess, from 8 to 8, right? You have full moons, right? Does that make sense? Has anyone seen around 8 the moon is full? It basically comes at the top. Has anyone seen the moon at 8? Where do you find the moon at 8? Has anyone seen the time zone, time range, जिस पे आपका moon is at the top of your head? If yes, can anyone share the time at what time the moon was coming at the top of their heads? Yes. So it's basically
सर सुबह
around,
के सर
yes,
सुबह के 8 बज रहे थे.
yeah, ठीक है, it's from 8
हम
to,
स्कूल में थे and it was like we could see it from there.
yeah, so it's basically 8 a.m. to 8 p.m., right? So if you see at 8 p.m. also, ठीक है, around the 14th of basically every month, you would see the sun, the moon is at the top, ठीक है, and similarly at 8 a.m. also, right? So again, the production system is basically very unreliable, right? Because the waves can basically variate, right? The speed can variate from time to time. So this will basically can be used to only for small systems, which basically can supply some island, right? Let's say if we have island वगैरह वहाँ पे we cannot send wires from cities, so we can use this particular phenomena to supply them with electricity, right? ठीक है, so every process has its pros and cons, right? Okay, so then we have tidal and hydroelectric energy, right? So I have discussed hydroelectric energy. I'm not going to talk about this in detail, but what about tidal energy over here, right? So tidal में क्या होता है हमारे पास? Is basically this. Let me read the context. Pretty simple, right? The flow of water from a higher to lower level is used to drive a water turbine, water wheel, right? Connected to a generator over here. In tidal energy, the water is held behind a tidal barrage barrier in an estuary, right? So basically, have you seen two things over here? We have barrage and we have dams. I guess you have studied the Pakistan studies and you have learned what are barrages and dams. Can anyone explain what is a barrage? What is a barrage and what is a dam? What is the difference between these two things? So they both can
सर
store.
डैम के अंदर पानी स्टोर होता है
Okay, what
बराज
about
के अंदर नहीं. और डैम के अंदर हम हाइड्रो इलेक्ट्रिक पावर भी जनरेट करवाते हैं.
perfect? Right. So dam can store water, barrage can only stop water, right? So this is the difference between those. And dam can also basically produce hydroelectric power, right? So barrage can only stop the flow for some time, and when you basically open the gates, it basically allows the water to pass through, right? Okay. So again, whatever we have studied for hydroelectric power, is that how is a hydroelectric power energy produced through using a dam? That is same applied for tidal energy, right? So tidal energy is basically produced in barrages. So barrages store water, right? So when they are open, they produce some pressure, right? And then again, basically leads to movement of a turbine, right? Again, what happens? Let me just tell you using block diagrams that it makes sense, right? Let me just draw from purple color over here. So we have a barrage over here, right? We have a barrage over here, and which does what? It basically lets water out, right? It is sort of stopping water, right? And this water basically then goes to a turbine. This goes to a turbine. Again, it's sort of a wheel, okay? Anything which rotates is called a turbine, right? So that basically produces mechanical energy, and that basically again is linked with the generator, which produces electricity, right? This is linked with the generator, which produces electricity, right? So what is happening over here? This is producing mechanical energy, right? Mechanical energy, and this basically is producing electrical energy, right? This is how every system is designed, right? I told you general system, right? Okay, in every system you would have a turbine that would move, that would produce mechanical energy, and with every turbine there is one generator, right? They convert that mechanical energy into electrical energy, right? So similarly over here, this is happening, right? Okay, so is this clear to everyone? If yes, thumbs up. Okay, clear to Hamza, Ruba, and clear to me, Varda. What about Mashal? Mashal, is it clear? Okay, clear to Mashal too. Okay, that's good, right? So these are systems, right? These are types of renewable energy resources which you are studying over here, right? It might pop in your theory, it might pop in your MCQ, right? So you should know, okay, how are they produced? What is the overall mechanism, right? Just learn this block diagram, right? Okay, so then we have geothermal, then biofuels, then we go towards efficiency, right? Okay. So what is geothermal energy? Okay. Let me just draw the diagram. It will make sense easily. So imagine this. This is the surface of the earth, right? This is the surface of the earth. Let me just draw the surface of the earth. This is the surface of the earth, right? And let's say we have a layer over here. Over here, basically what is trapped? We have high temperature over here, right? It can be basically near to core, the earth's core, which is pretty at high temperature. At high temperature. So what happens in this process is as follows. You have a water body over here. Let's say you have a water body over here, right? You have a water body over here. So this is your power plant, right? Let's say this is your geothermal power plant. Geothermal power plant. Say the PP is power plant. Okay. So now what do they do? They take the water, right? They take the water from here, from this pipe. Okay. And this basically goes here. The pipe goes in this region. Okay. And this is again linked with the turbine. Turbine. And this is basically linked with the generator. So can anyone explain what will happen?
Sir, can I?
Yeah, Ruba.
So basically, sir, over here the cold water will be pumped under pressure to the hot rocks present on the inside the earth. So basically, when that cold water will get on top of the hot rocks, they will produce steam. That steam will go to the turbine, which will rotate the turbine, making mechanical energy, and that mechanical energy is going to be then transferred into the generator, which will convert it into electrical energy, and that electrical energy will then be sent to our houses.
Perfect, right? Makes sense, right? So this is cold water, which is basically getting pumped to using some power, let's say water, vagara, and this goes to basically the hot layer of the earth, right? Where we have, let's say, approximately, let's say, 110 degrees Celsius, right? This basically makes the water into steam instantly, right? And then from here onwards, the red one, we have gas, not gas, we have steam over here, right? We have high pressure steam, which basically goes again due to high, since steam is in state of gas, it has high density. So since we know gas is low dense, it will rise up, right? So after it, the water pump basically only sends the water till here. The rest of the steam basically goes automatically upwards, and this basically moves to turbine, and this is basically linked with the generator over here, right? So this part again produces the steam. The hot steam basically does what? It rotates the turbine at very fast rate, and it basically produces mechanical energy, as discussed many multiple times before in our slides. And this again is linked with the generator, which again produces electric energy, which goes to your houses, right, industries, and so on and so forth, right? I hope it makes sense. So everything is written over here, and this is explained over here using a diagram. If it is clear, give me a thumbs up. Clear to Varda, clear to Ruba, Mashal, Hamza. What about Maeve? Maeve is clear. Maeve, are you here? Okay, clear to me. That's good, right? So again, let me just quickly skim what are they saying over here so that we can just mark the slide as done. So cold water is pumped down a shaft into a hot rocks in the below the earth's surface, right? Again, they convert this into steam, and this can drive a turbine and then again generate electricity using a to basically, let's say, heat the building, right? So geothermal energy that heats the rock is constantly being released by radioactive elements, okay, deep down as the earth decays. So they are saying कि by fossil fuels जब आपके पास decay हो रहे होते हैं, after some time they convert into natural gas also, right? So again, that also links to high temperature and pressure beneath the surface of the earth. So that basically helps to heat the cold water and convert it into steam, right? What is the disadvantage over here, right? They can only be built in specific locations where basically we have hot enough rocks to basically heat up the cold water into temperature where we can reach high pressure steams, right? Sorry. So again, we have to be specific about locations where we can build these particular setups because we need high pressure areas where we can have quick conversion of cold water into hot steam that can move the turbine and again generate electricity, right? Then we have biofuels, right? So what are biofuels? Biofuels are basically vegetable, right? Let's say आपके पास we have a vegetable which basically got rotten, right? And let's say the plant which died, right? So on and so forth. So instead of throwing them or let's say disposing them, we can use them for providing us with energy, right? So can you explain what is the idea of biofuels? Just by seeing this block diagram, right? Just by seeing this block diagram, can you explain what are biofuels? I want someone to answer this. It's pretty similar. So I explained what are biofuels. So biofuels क्या होते हैं हमारे पास plants के remains or let's say rotten vegetables which basically people throw out of their houses. So instead of throwing them on the garbage, we can use them, right? And China is doing that, right? Japan is doing that. Can you explain this? How would this process work with biofuels? Will it be same? Will it have some, let's say, different process throughout the chain? Yeah, I want someone to guess. Hurry up. Yes, it's not difficult. Yes, let me call someone now. मुर्दा अब बताएं.
ओके सर, बेसिकली वो जो आई गेस बायोफ्यूल से जो गैस लाइक बर्निंग से जो हीट जनरेट होती है, गैस जनरेट होती है, वो वी टर्न इट, वी टेक इट एंड वी टर्न इट लाइक टरबाइन से मैकेनिकल एनर्जी को उसको कन्वर्ट कर देते हैं और फिर हम उसको जनरेटर में लाइक इलेक्ट्रिकल एनर्जी को कन्वर्ट करके फिर होम्स में जाती है.
Okay, perfect. Right. So is it same as this block diagram? Can you identify the
यस
similarities? Yeah, it's same, right? It's almost
सर.
same. Every process of producing electrical energy is same, right? Just need a source to just drive the turbine, right? So over here we have breast burning fossil fuels, right? Sorry, not fossil fuels, biofuels, right? So biofuels क्या है हमारे पास? They are basically biomass. They can be also the waste of animals also, right? So cultivated crops, crop residues, remains, natural vegetation, coarse, ठीक है, trees, animal dung, sewage, right? So everything which is waste can be converted into biofuel, right? So what happens? Basically, when we eat food, right? What does food contains? Food contains what? Chemical energy, right? So any byproduct of this, let's say the remains, the waste of humans or waste of animals, the plants, right? They all contain chemical energy, right? So when we have chemical energy, we can basically combust it, right? We can combust it to basically what? Produce steam, right? If we have steam, then the entire process is same. That is this. If we have steam, that's one of the sources for moving the turbine. Then it's same. Move the turbine and then generator and then transmission, right? That's it. Chemical energy can be stored in biofuels such as alcohol, ethanol. Okay, I just crossed it. Ethanol, methane can be obtained from them by fermentation. So that's just saying what sort of fuels we can get from biofuels, right? And biofuels can replace petrol, right? But again, at a price of smell, right? It would smell pretty bad, right? Again, they are lead and sulfur free, so they would not produce any harmful byproduct for the environment that can lead to global warming or ozone depletion, right? So they do not pollute the atmosphere with lead and sulfur dioxide, right? Biogas is a mix of methane, carbon dioxide with an energy content of about two-thirds of natural gas, right? So what is the ratio, right? Let's say if we have natural gas, let's say if we have 1 gram of natural gas, which is producing, let's say 100 joules, right? So if you take 1 gram of biofuel, right, it would produce two-third of it, right? That is two-third is what? It's 66.67, right? 66.67 joules. Let me just do 6.67 joules, right? So that's not bad, right? That's not bad. Two-third is 66%. So that's not bad, right? So again, they have no harmful products like sulfur gas, sulfur dioxide, or lead gases, right? Which can basically cause asthma and so on and so forth, breathing problems in humans, right? But again, at a cost of, they would smell really bad, right? They would smell bad. Okay. So again, we can produce it from animal and human waste in digesters and use for heating and cooking, right? That gas can be used. Okay, so that is basically one of the last renewable energy resource which we have studied over here. China and Japan are using this, right? They are using this. They're burning the waste also. They're burning plastic, so on and so forth, and they're converting those waste into energy, right? That is some revolution which is happening in Japan, right? So we have learned basically how many sources of renewable energy resources. Let me tell you. So we have learned solar energy, right? We have learned solar energy. We have learned wind energy. We have learned and we have learned basically wave energy, that is again one of the renewable energy resources. We have learned tidal and hydroelectric energy, right? And then we have learned geothermal again, which is renewable, right? We just need water and we don't need to basically do any chemical reaction with the water, right? So this water goes into the hot rocks, it converts into hot stream that goes up, and basically this stream also comes back, right? इसके आगे we have one process which I don't want to tell you guys right now. They have to complicate things, right? So this steam is not wasted. This steam basically goes back to your water body, right? Through some process, right? If you want to discuss those, you can research. And if you want to ask some questions, you can text me on WhatsApp also personally, okay? If you want to add on to it. Then we have learned biofuel, right? This is again renewable, right? Waste is going to be there, right? Animal dung is going to be there, right? So they are renewable, right? They're producing it as soon as they are living beings on Earth, or till basically life is here, it can be produced, right? Then we have power station, right? So we have learned the processes through which we can produce electricity. But basically, what are power stations? Power stations are the regions, are the places where we basically carry out the process of generating. It is the region, it is the area where we basically produce electricity, right? Produce electricity, right? Where we produce electricity using the non-renewable or renewable energy resources, right? So can anyone tell me, has anyone seen a power station in their life, or let's say had a visit, had a school or college visit to a power station in their neighbors or in their area, right? Has anyone been to a power station? Or let's say, let me just change my question to, has anyone seen a power station video on YouTube? How does it work? If yes, give me a raise of hand. Okay, ठीक है. So कोई बात नहीं. So let me just tell you about one of our power station at Karachi, right? So at Karachi we have K Electric, right? So I basically made a visit to the basic three power plants of K Electric, right? Let me just write it down over here, K Electric. So they were huge, right? They were huge. They had these are motor, right? This is a motor. Just imagine this. This is a motor which was moving at speed of 1500 RPM, right? RPM means revolution per minute, right? Revolution per minute. So at 1 second, let me just tell you what does it mean. Revolution per minute. So this particular speed means, okay, in 1 second it was rotating 50 times. Right? That's very huge speed, right? At which this rotor is moving. Right? This is a motor which basically moves, produces mechanical energy. Right? This is one of the turbine over here. Right? This is a turbine also. It's a turbine. So basically होता क्या है, covered होती है पूरी. So basically steam comes like this. Right? This causes the basically turbine to move in this direction. Right? So this is one of the snaps from the inside the steam turbine. You can see it is a rotor of a steam turbine over here. So I have seen two power stations, which I also basically explained in the last recording. The first three basically we have been BQPS1, BQPS1, BQPS2, and BQPS3. मुझे roughly याद है values, ठीक है इसकी. So the first one was at around it was 520 something, right? 520 megawatt something. This was not 540, 340 something. It was around 340-ish. मुझे याद नहीं that values, ठीक है. Then this was around 520 megawatt, and the last one was 900 something megawatt. Right? I don't know exact values, but these are the ratings that what basically it can produce at its max. Right? If you combine it together, it comes around 1800 1900 megawatts. Right? So when I went to visit these power plants, एट मॉर्निंग जो पावर प्लांट होती है, रिक्वायरमेंट होती है फॉर लेट्स से कराची की रिक्वायरमेंट जो होती है इन द मॉर्निंग टाइम, इट्स अराउंड द डिमांड ऑफ इलेक्ट्रिसिटी was around 1500 megawatt, right? And the plants are producing it, right? And they are producing it, right? Exactly. They're producing it 1500 megawatt also, right? It was around 3 p.m. in the in the afternoon, right? So again, what is the power? ऐसे बच्चा इनकी efficiency कम होती है, right? So thermal power plant जो हमारे पास हैं, which Pakistan, which basically they are power plant, right? Which are thermal power plant. These all are thermal power plant over here, right? These all are thermal power plant. जो कराची में, जो पाकिस्तान में सारे मेजोरिटी ऑफ थर्मल पावर प्लांट होते हैं हमारे पास. वी हैव फ्यू ऑफ देम व्हिच आर सोलर पैनल सोलर बेस्ड आल्सो, व्हिच आर बेसिक हाइड्रो इलेक्ट्रिक पावर बेस्ड आल्सो, बट दे ओनली प्रोड्यूस कंबाइंड, लेट्स से कंबाइंड वगैरह, दे ओनली प्रोड्यूस 200 मेगावाट मैक्स कंबाइंड. सो ऑल द रिन्यूएबल प्लांट जो हमारे पाकिस्तान में है, कंबाइंड दे प्रोड्यूस ओनली अप्रोक्सीमेटली टू 200 मेगावाट रफली, ठीक है. सो we have coal in we basically import the fuels from Iran, right? And we burn them, we produce steam, and this basically steam causes the rotors to move, and this rotor is turbine is linked with a generator that produces electricity, right? So the efficiency, we will learn about efficiency, right? So can you explain what is efficiency? What is efficiency? Yes, what is efficiency? Thermal power plant is 30% only. What is efficiency, Mashal? Yes, Mashal. Is Mashal here? Guys, am I audible to you guys? Clear से बोल रहा हूँ मैं. बात आ रही है?
Yes.
Okay.
Yes.
Mashal, are you here? Okay, let me call anyone else. I guess she is having a cup of chai or something. Yes, Ruba. Explain what is efficiency. I believe Ruba is here.
Yes.
Okay.
It is basically the input taken and it generates the output. It is never 100% because some energy is also wasted during the production.
Mm-hmm.
So, yeah, I have a rough idea about it.
Yeah, so basically efficiency is telling you कि एक process, you have a system, you have a process, right? You have a process, it can be anything, right? You have some input, right? You have some input, let's say input energy, and this is basically mapped into some output energy, right? Output energy. So the efficiency is basically telling you that how much input energy is converted into output energy. Let's say it was 100 joule of input and the output is only, let's say 30 joules, right? So if you want to find the efficiency, that would be the output energy upon input energy times 100, right? You see the formula now, while okay, what is the formula? So it's 30%, right? The efficiency is 30%. Let me just use a correct symbol over here for efficiency. It's called eta, right? We will call it out. It's called eta over here. This is efficiency over here, right? Okay, so let me just now move on. So we have now the different section of the lecture which is talking about efficiency, right? So let's start on efficiency, right? Okay. So now, this is just showing the variation in power demand, right? What is power demand? Okay, how much energy is required by the city at a particular amount of time. Okay. So zero is basically let's say midnight, right? So when it hits midnight, it becomes all zero, right? And then as soon as you go up the day, okay, so it's in 24-hour clock format, right? So let's see how is the power variating over here. So in summer, you can see the demand is very low, right? However, in winter, the demand increases over here, right? Does that make sense? So basically, let's imagine this is for a country उसकी summer में we need less energy, right? I mean, we need more. Okay, yeah. Let's say it is, mm, let's say Toronto, right? It's a city of Canada, right? So in mid summers, they don't need to use any heaters or any, let's say, water heaters or basically some systems which the central heating systems which keep the houses warm, right? So they need to spend a lot of energy on just keeping their houses warm and their water warm, right? Because in Toronto's a city, the temperature is negative Celsius, right? So in summer, the temperature is not. In summer, they don't need to turn on that many number of heaters. Okay, that many number of electric appliances. So the demand is low, right? In summers. However, in winter, the demand exceeds. You can see the demand is very huge, right? It's greater than the blue curve over here, and this is because of they need energy for running their heaters, their central heating systems, and so on and so forth, right? This is basically just a graph to show a demand, right? Demand variation. Okay, so some economic, environmental, and social issues over here. So can anyone tell me, okay, we have these processes over here, right? We have learned about processes which are some non-renewable and some renewable over here, right? अच्छा जी, ये हमने पढ़े थे. Let me just take you over there. We have learned these processes. अच्छा जी, let me just close this. Yeah. So we have learned about energy resources, इसकी types, right? Renewable and non-renewable होती हैं. Then we have learned about non-renewable energy sources, ठीक है, that are fossil fuels and nuclear fuels, right? And then we started on topic of renewable energy resources. We had talked about solar, we talked about wind, ठीक है. Then we talked about tidal energy, wave energy, right? Then we talked about tidal and hydroelectric power, geothermal, and biofuels, right? Then we talked about some power stations over here, how do they produce the system, right? What do they produce and how efficient are they, right? Okay. Now we have some economic and environmental and social issues over here, right? So just imagine you want to decide, right? You want to decide you want to use whether renewable energy resources or non-renewable energy resources, right? You want to choose one of them, right? So you want to basically compare the pros and the cons, right? So this particular section is basically telling you what factors do you see when you decide, let's say you want to let's say if you are given a choice, right? Let's say you are an engineer and you want to choose कि आपको एक project दिया मैंने, let's say Ruba, you want to make a power plant to basically support a town which needs, let's say, 200 megawatts, right? So you are given basic multiple options. You can make a solar power project, right? You can make a hydroelectric power dam. You can make, let's say, a fossil fuel power plant. You can make a coal burning power plant, right? You can make any power plant, right? So you can use either renewable or non-renewable, right? So you want to weigh the pros and the cons, right? So what pros and cons will you be looking, Ruba, when you are given this question, or let's say this choice?
Um, the availability of the site,
Good.
uh, what source is in bulk to us. I would prefer solar energy because
Mm-hmm.
sun is obviously shining. And for what if I choose water? So water is not very much present in Pakistan in bulk amount. So I would choose solar energy for that, and if it is environmental friendly or not, because we need to keep our environment good because
Good.
because of the global warming.
Mm-hmm.
And what will I say? Uh, yeah, I can think of these points right now.
Yeah, that's good, right? So Ruba covered all the dimensions, right? She said कि सर मैंने लिखना है कि it should not destroy the environment, right? It should not produce very harmful products, and she also needs to think about the availability, right? So is that water available, right? Is the land available that much that we can produce? We can put, let's say, 6,000 solar panels on a certain region, right? Do we have that enough space, right? Let's say if I want to put a wind power plant, right? Do we have enough space? Do we have enough speed of wind which can move the turbine, right? So we need to see all of those dimensions when we want to basically put up a power plant, right? Also, the most important factor which Ruba missed was the cost of producing it, right? Okay, how costly is your electricity, right? Because who are your consumers? The people, right? The people of those particular area, right? They would be buying the electricity from you. So obviously, let's say it's a village, right? They cannot pay huge amount of taxes, or let's say huge amount per unit, ठीक है, for electricity, right? So you want to see those factors also, right? You also, let's say it's a village, right? You want to keep the cost to a minimum, right? That is a very important factor which you want to keep in mind when you are making a power plant, right? So it depends upon. So similarly, Pakistan में यही issue है. So Pakistan में when I basically talked with an engineer over there at KLRT, so he explained these dimensions to me, right? So he said that the main important factor when we make a power plant is cost to us, right? because due to economic crisis, you can see कि अभी 1 unit is basically 45 rupees in Pakistan, right? So 1 unit is 45 rupees, right? So if you talk about 2010, it was 12 rupees, right? So that's how much it has increased, right? So on an average, let's say on an average of a single house, take care of let's say if we have an average house in Pakistan, so you would consume around let's say 300 units, right? Consume about 300 units. So if 1 unit is of 45 rupees, right? How much you have consumed? This is just an average over here, right? This average house को मैं बता रहा हूँ कि इसके अंदर it doesn't have any AC, air conditioner. They don't have any dispenser, ठीक है? They don't have any uh let's say heaters in their houses, right? That's an average house, right? This is the average value, right? Which came across the research. So this is how you want to decide, right? So that's they in this particular two slides we are comparing these factors over here, right? These are pretty important, right? So आप engineer तो हैं, but you also want to think. You also want to think what are you doing, right? And we also want to make a very informed decision about your choice. Okay. Okay, so let me just move back. My PowerPoint just died. It came back to life. Okay. So now let's start it out. Okay. I'm gonna quickly review go through this and let me know, okay, if you have any questions. So environmental problems such as polluting emissions that arise from different energy sources were outlined. Okay, so we have seen this. What polluting agents basically are produced in different processes, right? So apart from people from using less energy, how far pollution can be reduced by, right? For example, we can install this process over here, okay, in a coal burning power station. So this process is will be learned in your chemistry class. Okay, if someone is taking chemistry over here, okay, so you will learn this process. So this is called desulfurization. It basically removes sulfur dioxide, right, from pollutants. So basically, when you have combustion वगैरह in coal-powered power station, right? So you have sulfur dioxide produced, also, right? So it converts. It basically this is a process. It basically absorbs sulfur dioxide, right? It removes it from the product, right? So that helps to save the environment, right? So although there are no fuels costs associated with electricity generation from renewable energy sources such as wind power, energy is so dilute that the capital cost of setting up the generating solution is so high, right? So for renewable, we don't have any running cost, right? For renewable, we don't have any running cost. What is running cost? What is running cost? You don't have no running cost. So running cost क्या होती है? Let's say if I have a coal burning power plant, so उसको चलाने के लिए I need coal, right? I need to buy coal constantly. But for renewable, right, like say solar energy, solar to free, right? Sun is free, so I don't need any fuel right over here. There is no fuel over here. The cost of buying fuel is removed in renewable energy sources. But the issue is that for let's say for wind over here, I need to set up a huge area, right? So that again leads to high cost of setting up, right? Again, that is a very informed decision. Let's say the government has no funds. Okay, let's say the government has no funds for putting up such a huge power plant on a certain area, so they won't be allowing it, right? If they don't allow it, you won't be able to build it, right? So it has been estimated that currently it costs between 9 to 22 US dollars to produce a unit of electricity in a gas or coal powered in UK, right? So this book was published in 2018, right? So ये 2018 के facts हैं. These facts are basically of 2018, right? So on average in UK, this is 9 to $22 over here. So if I talk about Pakistan right now, okay. So for renewable, we have 15 rupees, right? So we have Sky Electric, which use solar energy, right? So it is basically 15 rupees right now. ठीक है, फॉर नॉन रिन्यूएबल जो पाकिस्तान में केएलटी के प्राइस हैं दैट इज बेसिकली 45 रुपीज, राइट? So this is the difference between the cost per unit of renewable and non-renewable, right? अच्छा जी. So again, this can be read by you guys बाद में. So this is how we want to basically see it. Okay. Again, we need to weigh some pros of types of non-renewable energy sources, right? We can use natural gas. We can use basically coal powered. ठीक है, we can use either of them. But benefit क्या है for using natural gas? It has a short startup time, right? What is startup time? Let's say when we turn on the system, right? Let's say this is a power plant over here. This is a plant over here. I need to turn it on, right? I need to turn on this. So that there is some time which basically is taken to start the process, right? I need to basically start the turbine. I need to heat up some water, right? and then I need to basically link the turbine with the generator, right? So this heating up of the water and then water starting to move the rotor is called startup time, right? Okay, this is called startup time. So in coal power and oil power station, it takes longer to start, right? Because for burning coal or burning oil, it needs some time to heat it up, right? Because coal burns at very high temperatures, right? But benefit क्या है? They are reliable, right? Let's say at 8 p.m., 6 p.m., 5 p.m., 3 p.m., 3 a.m., 4 a.m. Whenever I need to turn on power, I can just start burning up the coal and the power station can be turned on simply, right? But not in wind and sun, right? This is not possible in wind and sun. So they are unreliable, right? So these processes are unreliable. Let's say the day is cloudy, right? The day is cloudy, so there will be no sunlight. If there is no sunlight, there is no solar energy, right? Similarly for wind, let's say if the winds are not flowing, the turbine will not move. If the turbine is not moving, there is no wind energy and there is no electricity, right? So that is basically some drawbacks of using solar energy, right? So again, we are using renewable sources right now, but on a small scale, right? Not at a big scale. So we are improving. We are basically working on some steps or some methods which can basically lead to for increasing basically making the renewable energy sources more reliable. So we are making basically converting this into, let's say, as soon as there's sun, so we basically are saving the energy in batteries, right? So in solar power at houses, what is happening in the daytime? The solar panel is working, and they have also batteries, right? So batteries are charged up during the daytime, and when the sun sets, basically the battery is now powering up the entire house, right? So there are processes, but again, expense, right? They're expensive. You want to put up, let's say, 15 to 20 batteries, huge, the truck battery, right, for storing energy. Okay, so this is a breakup of the entire use of energy sources throughout the world. Right? They are telling ki what is the majority of the country or basically majority of the world using as the power producing source, right? So oil is used 34% for producing the electrical energy throughout the world, and coal is used 27%, gas is 24%, nuclear is 4%, hydroelectric is 7%, right? So if you combine these up together, these all are non-renewable, right? And this is only the renewable over here, right? You can see the difference, right? And why do we need to use non-renewable energy sources? Because it produces huge energy, right? We have industries, we have power, we have jets, we have fossil fuel, we have basically steam engines, we have trains. Okay, all of them need basically high energy density, right? That is why we need to use a quick energy producing energy sources which are non-renewable, right? Hydroelectric is used, but only 7% throughout the world, right? And this the 70.3 table is basically telling you okay, what is the energy consumption, what is the demand of country per year. Okay. So North America need 240. Basically, this is in exponent 9. Okay. So it is 240. 10 to power 9 is mega tera giga. Okay. Gigawatts. Right. UK basically needs 121 gigawatt. Right. So we can just see okay, what is the requirement of energy throughout the world, right? Pakistan at this time, which was 2018, needed around 20 gigawatt of energy, right? It is pretty accurate values, by the way. Okay. So what is efficiency, right? Imagine that we have a car, right? Let's say we have a car. So we have, let's say, a bike. Okay. So obviously, 100, it is not 100% efficient, right? In the car, we have piston, right? Which basically undergoes friction, right? So we have some certain losses over there. Again, if you basically feel your engine area, let's say the bonnet of the front part of your car, it basically gets heated up, right? Because of production of energy, right? Combustion of the, so we have energy release over there. So we have certain factors which basically leads to loss of energy. So we need to cater in efficiency, right? So what is efficiency? It is basically dictating how much of your power that is produced is useful for the consumer and how much is lost, right? That is efficiency. So does anyone has an example to basically describe efficiency? Any example from your real life, whatever you have seen in your real life till now? Yes, anyone. Give me a tuka. We don't care if it is wrong or right. We just have to participate over here. Hamza, आप बताएं. Hamza, are you here? Hamza, speak loudly and get closer to the mic.
आवाज आ रही है?
और थोड़ा जोर से बोलें.
आवाज आ रही है?
Yes, it's good now. It's better now. Can you give me an
सर,
example of
the
efficiency?
efficiency, सर एनर्जी जब भी किसी एक फॉर्म से दूसरे फॉर्म में जाती है तो उसमें एनर्जी लॉस्ट भी होता है, तो जो एनर्जी सक्सेसफुली यूज हो जाती है ना दूसरे फॉर्म में जाके, उसको एफिशिएंसी ऑफ एनर्जी बोलते हैं।
अच्छा, नहीं, एनी डू यू हैव एनी एग्जांपल इन हेड, इन योर माइंड के यहाँ पे एफिशिएंसी आपको पता हो कि लेट्स से एफिशिएंसी यहाँ पे
सर
50% है, 40% होती है, क्यों होती है?
कैंप फायर में किसी कोई
Yes.
फायर।
Okay, so Mashal is saying in cars we look for those which are fuel efficient. Yes, that is good thing over here, right? So efficiency basically are you can find it in cars, right? Let's say if you want to drive more number of kilometers in basically you want the car to consume less fuel, right? And it should travel more kilometers in a full tank. So that is efficiency, right? So how many kilometers are you traveling per liter, right? Again, let me just give you an example, right? Let me give you an example. Let's insert a blank slide over here. Okay. Let's imagine you have a car, right? And my ink is not working. It's working. Let's say this is your car, right? It's just a black box. It's your car, right? And this is your output, right? And this is your input to the car, input energy. This is your input energy over here, and this is your output energy, right? Basically, the useful energy जो आपकी कार ही आपको दे रही है. So what is the input to the car? What is the input to the car? Which thing drives the car?
Fuel.
Yeah, fuel, right? It's petrol. It's petrol, right? Oh my God, my spelling is petrol is petrol. It's petrol. Let's say आपने petrol fill करा, we should give you 1,000 joules, right? And the energy which is basically causing the wheels to rotate is only, let's say, 800 joules. Not 800, it's 30%. 30% कितना होगा? It's going to be 20% कर लेते हैं. 100 joules. 200 joules, right? So your output from your car, which is basically moving the wheels, is only 200 joules, right? So there might be a question over here, right? So where is the remaining energy, right? So the remaining energy went as waste, right? This is your loss over here, right? This is your loss of energy, right? Loss of energy. So the remaining 800 joules is wasted, right? And wasted in what? Wasted in friction of pistons of engine moving parts, wasted in heat, right? Wasted in heat release, and it is also wasted in what? In form of sound energy, because when you start up a car, obviously it produces sound. So there is also some waste of energy in sound energy form, right? So these are the form through which your energy is getting wasted over here, right? So this is your Sankey diagram, right? It's called Sankey diagram. Sankey, right? It basically dictates all the inputs and all the possible outputs, right? This is called a Sankey diagram, right? So this is acha. Now I want to find out, right, what percent of my energy is getting transferred to output. I want to basically find the relation between input and output over here, right? So if I want to relate these two terms over here, so I have a new term which is called efficiency. That is shown by eta. This is called eta. It's a rate term over here. And this basically dictates the ratio of over input, right? It says that it is equals to output energy divided by input energy into 100, right? And by 100, because we want to find percentage, right? Percentage is always 100. So that is why we find multiply this thing with 100 over here, right? So this efficiency, so this is called efficiency. So this links that how efficient your system is, right? This is called the idea of efficiency over here. Can you give me an example of a system that is 100% efficient? A system which is 100% efficient. Do you have an example in your head which is 100% efficient? I'm not bluffing over here. It is correct, right? There is a system which is 100% efficient. Can you guess? Hurry up. I want to move on. Yes, Ruba. Can you guess? Which system is 100% efficient?
No idea, sir.
No idea. Okay, that's honest. You might be surprised. Okay, that is your iron press, right? That is your iron press. Why? So let me draw the block diagram over here. So this is your iron press over here, right? This is your iron press. What is the input to your iron? It's electricity, right? It's electricity into your system. And what is the output? You basically want heat energy, right? You want to iron your clothes. Okay, so you want your output to be heat energy. Okay. So whatever basically losses occurs, they also produce heat, right? The function of iron also basically to produce heat. So all of the wasted energy and the useful energy is in the form of heat energy, right? So if you just map it out, if you're basically supplying 100 joules of electricity, it will produce 100 joules of energy, right? Does that make sense? The efficiency of the system is 100 upon 100 times 100%, right? So that gives you an efficiency of 100%. If it makes sense, give me a thumbs up.
Sir, how is it 100% efficient? Like heat energy is the same as the electrical energy given to the device to
क्या
iron.
हमारे जो लॉसेस होते हैं सिस्टम के अंदर वो किस फॉर्म में होते हैं रुपा
Heat losses,
हाँ
sound
तो आयरन
losses,
का मेन पर्पस क्या होता है
to heat.
या सो एवरीथिंग इज combined together to produce heat energy.
Yeah, got it.
So there are no losses over here, right? If it makes sense, give me a thumbs up. If it makes sense, give me a thumbs up. I want to move on, guys. It makes sense to Ruba, Hamza, Mashal. What about Varda? Is Varda here or Varda is in parallel universe? Thinking about what is life, sir?
No, sir, I'm here.
Yeah, yeah, okay. Does it make sense? Okay, it makes sense. That's good. Okay, so this is the ideal efficiency. So this basically tells you how much useful energy is getting produced by the system, right? So the relation, the formula which you want to use in your calculation in your exam is this. That is useful output energy. Useful, not the wasted wala. Okay, it's useful output energy upon total energy input times the 100%, right? So we have 100% because we want to scale it from 0 to 100%, right? Okay, so this is efficiency, right? I hope it makes sense now. We have done an example also. So this is again the formula which is in the definition. So if you have a question in your exam of 1 mark, okay, if they ask you what is efficiency, so you should just define this definition in terms of your own words, right? So this is a ratio of useful output energy and total input energy, right? That is called efficiency, right? So what is efficiency? And the answer is at within this particular key definition over here, right? Okay, so this should be a question mark. My English is getting weird. Okay, so surprisingly for an engineer, okay, your writing should be good, but my writing is not good, right? But your spelling can be wrong, okay? They doesn't care about your spelling. They only care about your mathematics and your analysis, right? So your calculation stuff should be correct. So for us, for engineers, you don't need to care about spelling. So that is why I do a lot of blunders over here. But the writing should also be good. But that is also not my strong end, right? So voila, you have me, right? Actually, so now you have some efficiency kill relations values over here, right? So electric motor जो होती है हमारे पास गाड़ियों के अंदर होती है. If you have seen electric vehicles, right? तो उनके अंदर motors लगी होती है. ठीक है. Let's say if you have a motor which pumps water out of your, let's say, or from the ground, that is also a motor, right? Large. It should be a large because it pumps the water at a very high rate. Generator, right? Let's imagine you have your school and let's say if you're living in Karachi, there is a possibility that you might get load shedding, right? You might get some power outs. So they have the generators in their basically campuses. So they have a huge generator, right? So generator का purpose क्या होता है? Converts the petrol to electrical energy, right? So it should be efficient because the petrol is so expensive in Pakistan. And if it is not efficient, the school, the college, the university might be facing a lot of losses, right? So that is why they have very high efficiency, right? So motor is 90% efficient, and electric generator is basically 90% efficient over here. So 90% efficiency क्या होती है? Let's say if this is your system over here, this is called a generator. If you give 100 joules of input, you're getting 90 joules of output, right? That is a good efficiency over here, right? That is 90% efficient. Okay, so the domestic gas boiler, right? Let's say we have boilers in your homes which heats up your water, right? In winters, and compact fluorescent lamp, the LED bulbs which you have in your homes, ठीक है? Steam turbine, which are used in power plants, right? These are used in power plants, which we have seen. Power plants have an efficiency of overall 28%. Why? Because it contains a steam turbine within its system. So the entire power plant, this is the entire power plant. It consists of different components. So a component is called steam turbine, right? ठीक है जी? So its key efficiency is around 45%. So if I want to find the overall efficiency of this entire system is 28%, right? So you can see the reason कि इसके जो components हैं, ठीक है, the part which from which the power plant is made up of has very low efficiencies. Therefore, the overall efficiency of the system is very low. Again, जो आपके पास कार्स हैं, ठीक है, द आइस कार्स, द इंटरनल कंबशन इंजन्स, नॉर्मल कार जो आपके पास घरों पे हैं, विच बेसिकली कंज्यूम्स पेट्रोल और एलपीजी और सीएनजी, ठीक है, दे आर ओनली 25% एफिशिएंट, ठीक है, दैट इज अ ह्यूज ड्रॉबैक. लेट्स से अगर आप 100 जूल्स ऑफ पेट्रोल भरवा रहे हैं, लेट्स से ऑफ 250 रुपीज, राइट, यू आर ओनली गेटिंग, लेट्स से, लेट मी जस्ट रीड्रॉ इट अगेन. इफ यू हैव a car over here, let's say this is your car, right? And this is the input, right? Let's say if you're putting in 1 liter of petrol of which is producing 100 joules, getting only 25 joules of energy, right? Let's say 100 joule, 1 liter petrol अभी जो चल रहा है, that is 251 rupees, right? ठीक है जी. So if you can find out the amount that is basically getting utilized to produce the useful energy, right? So it is 1/4. This is 250 का 1/4 कितना होता है? It's 50, 60 something, right? 54, 75 something. ठीक है. So this is the only useful amount of energy which your car is producing per liter, right? That is a huge loss, right? Let's just imagine कि आपके पास टरबाइन, आपके गाड़ी के अंदर पिस्टन्स होती हैं जो मूव कर रही होती हैं, राइट, कंबशन हो रही होती है, साउंड एनर्जी प्रोड्यूस हो रहा होता है. सो देयर आर सो मेनी लॉसेस इन योर कार इंजन, राइट? Filament lab which you have in your homes, the yellow ones, right? The peeler bulb, which we basically call it like this, which is like this. The yellow bulbs, which were basically the invention of Nikola Tesla, sorry, Thomas Edison, right? This was the invention of Thomas Edison, right? It basically contains a filament lamp. Filament cutting करता है, which basically glows. When the current flows through a filament, it basically glows, right? So this was the first invention which basically produced light. So this is only 10% efficient. Imagine this, ठीक है? अगर if you're giving 100 joules of energy, it only produces 10 joule की energy. बाकी energy is lost in form of heat, right? That's how inefficient these are, right? That is why they consume huge amount of energy, right? So when you can do a test in your home, right? You can just replace your all LED bulbs with your filament lamps. Okay, then in the next month, you would get the result in terms of your electric bills, right? It would produce huge amount of bills in your next month, right? Because of the inefficiency, right? Again, अच्छा, efficiency formula ये भी होता है, right? So if we use energy output upon energy input, we will learn the relation of power in the next slide. Just imagine this. We can find efficiency using two formulas. Okay? That is energy output, E out upon A in times 100%, or you can find out the efficiency using power also. Okay? The power and energy are basically bent by of each other, right? They're pretty close to each other. How? We see in a while, right? Times 100%. Right? You can find efficiency using these two formulas. ठीक है जी? Does it make sense till now? If yes, thumbs up. Makes sense to Ruba, Varda, Hamza, and everyone. That's pretty good, right? So now we have the last topic of of this chapter. Then we move on towards the question answers. So hopefully, uh, in the next class, we will have. I guess we won't have time. So in the next class, you solve the questions together, right? So in your test will be in the next week, inshallah. Okay, Dee. So we have some questions over here.
Sir,
Yeah.
sir, next week Saturday से मेरे एग्जाम्स हैं.
Yeah. So
So मतलब मैं टेस्ट दे तो नहीं पड़ा. I just wanted to know.
yeah, test basically आपके I just want a test is there to basically make you guys read the slide for once, right? वरना आप पढ़ते नहीं है आप लोग. ठीक है जी? ओके जी.
10 दिसंबर के बाद रखेंगे.
हमजा का सवाल है. हमजा भी परेशान है. हमजा बोले. So we'll discuss about the test in the WhatsApp group. ठीक है? So don't worry. So start with this question जल्दी से. So you have a question over here. आपके पास मोटर है, इलेक्ट्रिक मोटर है, जिसको आप 400 joules of energy input दे रहे हैं, and is lifting a weight of 200 Newton through a vertical height of 1.5 meters. We want to find the efficiency of the motor, right? Okay. So I want to find the efficiency of the motor. So let me write down the formula. So efficiency in terms of energy is E out upon E input times 100. Right? Jaldi se solve करें the question. And when you're done, raise your hand. Okay, जी. So I guess let's start the solution. ठीक है. So we will stop after this question. So let's do this. कि we will start from here. Then in the next class that is on Sunday, right? So we cover it out from the next class. So उसमें यही होगा कि हम क्वेश्चन आंसर हाथ के हाथ सॉल्व कर लेंगे ना, वरना फिर आज सॉल्व करेंगे फिर आप संडे को भूल जाएंगे अब लोग क्या करते हो. ठीक है. So let's start and solve it out. I'm going to solve A and B. ठीक है, together. So you have this, right? So how do you solve this question? These are your typical questions in your MCQs and theory job exam, right? So you have a system. Just remember this. Okay, you have a system which is a motor, right? This is a motor. So you are giving 400 joules of energy and you're getting some output, right? E out. You don't know what is the E out, right? But आप इन लोगों ने आपको कुछ बताया हुआ है कि कुछ काम कर रहा है. It is doing some work over here. It's lifting a 200 Newton of weight through a vertical height of 1.5 meters, right? So this is a motor. Imagine this is the motor over here, and this is the weight, right? So it's lifting this particular uh, weight of 200 newtons in this direction of 1.5 meter, right? So distance or force same direction hai. So I can apply the idea of work done, right? So we have learned what is work done. So work done is basically force into distance in the same direction as that of the force, right? It's F into D, right? So isse we also learned that work done is also same as energy, right? These are interchangeable terms. So therefore your E out is force, that is 200 newtons, into the distance travel, that is 1.5 meters. So what do you get? You get basically what? You get 300 joules, right? 300 joules of energy. Okay, so now you simply want to apply the formula of efficiency, that is as follows, right? So you want to write down the formula. एक mark इसका होता है. That is E out upon E in times 100%, right? So you have E out as 300 joules, you have E in as 400 joules, and times 100%, right? Joule and joule cancels out, so efficiency has no unit, it has only percent sign, right? So it's 0 cancels out, so 3 upon 4 is 0.75, so your efficiency of this time is 75%, right? That's not bad. That's not bad, right? That is the answer, right? So who got the same answer? Give me a thumbs up. Who got the same answer as this? Acha, Ruba got the same answer, Vardha got the same answer, Mashak got the same answer, Hamza got the same answer. That's good. That's good. Okay, that's pretty good. So now I'm gonna quickly solve. Acha, we have only 2 minutes. I'm gonna speed up. Okay. So let me just speed up. So now we have this system over here. So if the energy input to an electric drill is 300 joules per second, it transfers 100 joules per second of energy to thermal energy, right? Calculate its efficiency over here, right? So यहाँ पे they have an idea of joules per second, right? So we have a system over here, okay, that is electric drill, okay. So what is happening over here? It is transferring. Let's keep the time to 1 second, right? So in 1 second time of interval, the E input is what? The E input is 300 joules, right? So don't be confused के साथ joule per second दिया हुआ है. So the E out is basically what? The E out is 100 joules, right? That is not E out, that is the wasteful energy over here, right? So guys, rejoin for 5 more minutes. The meeting is about to end, right? Rejoin. Okay guys, let's continue. So यहाँ पे गौर से पढ़ें क्या दिया हुआ है आपको. ये गिवन कि what am I audible first of all? Am I audible?
Yes.
Okay, ठीक है. So यहाँ पे आप इन लोगों ने दिया हुआ है कि what is the energy lost, because it is saying कि it is transferring 100 joules per second to thermal energy, right? Thermal energy, heat energy, which is lost, right? So the E loss is given to you, right? The E loss is given to you over here that as 100 joules, right? Acha, if I want to write a equation which links total input energy over here, that is E input is equals to basically what? This is your E out, right? So your E input is equals to E out plus E loss, right? Right? So this is how the energy are linked together over here. Okay? So if you want to find the E out will be what? Just rearrange the equation. So E out is E input. So this basically comes from conservation of law of energy. Energy cannot be lost nor destroyed, but it can change from one form to another form, right? Conservation of energy equation money. So your E out will be E in minus E loss, right? So your E in is going to be is 400 joules, not 400. It's 300 minus 100. So your useful energy which your system is getting from 300 joules is only 200 joules, right? I hope it makes sense. This is your 200 joules. Now you have E out, you have E in, so you have the formula. You want to find out the efficiency, right? Now it's straightforward. Okay, so just let's find out your efficiency over here. So your E eta, your efficiency is basically the E out over E in. times 100, right? Percent. So your E out is 200 and your E input is 300 and times 100%. So your zeros and zero cancel out. 2 upon 3 is 6.66, sorry, 0.667. So it is 66.67% efficient, right? Okay, so this is basically the idea of efficiency, and we have solved questions. So efficiency questions से ही आते हैं बस, ठीक है, इससे अलावा नहीं होते. So you would have to just find out the output energy, right? You can either find out the output energy using Voight-Wall idea, that is force into distance. You can find output energy using this equation, K E input equals to smaller definition for this. If you want to summarize the definition of power in a small set of words, that would be as follows: that power is the rate of exchange of energy, right? Whenever we have rate, that means कि जो quantity बाद में आ रही है, that is going to divide, that is going to get divided by time, ठीक है? So power is basically energy upon time, right? This is the relation of power, energy, and time. Okay, so since we know from our last lecture that work done is equivalent to energy, so we can also replace this E by work done, right? Since they both are measured in joules, therefore power is also equals to work done over time, right? So let's go through the definition over here. What is your textbook saying? The more powerful a car is, the faster it can accelerate or climb a hill. That is, the more rapidly it does work, right? So what is the power? Power is of a device is the work it does per second, right? Power is the rate at which it does work, right? This is the same as the rate at which transfers energy from one state to another state or one store to another store, right? So this is the formula which links power, energy, work done, and time, right? So since work done and energy are interchangeable, so you can use this formula over here. Okay, and again, this is just summarizing the formula in terms of variable states. And let me just write down what is E over here. E is your energy transferred. E is your energy transferred. W is your work done. And T is your time taken. And obviously P is your power. Okay. Acha, now since we are done with this, I want to ask a question. Okay, what is the SI unit for this? What is the SI unit for power? What is the SI unit for power? Yes, Ruba. What is the SI unit of power? Is Ruba here? Okay. I guess she's also having some internet issues over here. What? Okay. Mashal says what? Okay, that is absolutely correct. So how do we measure energy? Energy is measured in joules. T is measured in So T is measured in seconds. Okay. So if we use the base quantities, the power SI unit is basically joule per second, right? This is also basically known as watt, right? It's not WHAT, it's WATT, watt, right? So James Watt was the person who discovered power. That is why it is named watt, right? Okay, so there might be a question in your exam that says, okay, what is 1 watt? Define watt only. Define watt. They gave me a question in your exam that is as follows: define watt. So how can we define this? What should be answer for this?
Sir, it's the unit for joules per second.
Yeah. So whenever you have a question like this, whichever when they ask about the SI unit, you would define what, always refer to the formula, right? So formula for power is joules per second. So you can just use the formula, right? So if we have power equals to 1 joule over 1 second, that equals 1 watt, right? Just use this definition to describe what, right? So 1 watt is the power transferred when energy of 1 joule is transferred in a time of 1 second, right? Or can I say कि 1 watt is 1 joule per second? ठीक है, either way is fine. ठीक है, if you want to be straight to the point for 1 mark, that is also correct, right? So this is the SI unit for power. Is it clear till now? If it is clear till now, give me a thumbs up. What? Okay, we know now what is power. We know how to measure it. We know what is the SI unit of this. Is it clear to Mashal? It's clear to Mashal too. Okay. So again, this is the definition which you should basically write in your exams, which we already had done in the last slide. Power is the work done per unit time, okay, or it is the energy per unit time, okay. Either way is fine. So the power unit is basically watt, and it is the rate of working 1 joule per second. If you want to define watt, so 1 watt is 1 joule per second, okay. Then we have kilo mega. We had done this already in your chapter number 1, right? If you remember, kilo is basically equals to kilo, and it has the power of prefix of 10 to the power 3. Capital M is mega, and it has a basically next power of 10 to the power 6. That is just written over here, right? If there's a question in your exam, what is 1 M, capital M, capital W? So you should choose the answer for this option, right? 10 to the power 6 watts, right? So usually we have power in megawatts, kilowatts, okay, for power plants. We discussed this in the example of Pinkasi power plant of Karachi Electric, right? So that is the reason over here, and that wraps up your chapter.